Thank you for joining us today. Hello, my name is Karthika Raman and I'm your host today. A little bit about me. I'm a senior technical marketing manager here at Microsoft. I've been here for 6 years. All of it has been with the SQL Server team. I currently focus on Azure SQL Database and a couple of data services. And now moving on to what the session is about today. So today we are going to talk about Azure SQL Database. We have currently four course modules scheduled. The first one will be about an introduction to Azure SQL Database. We'll talk about why it's a great solution for business-critical applications. We'll talk about the new service tiers and the new business continuity features, and then get an overview of the performance. In the second session, we'll go a little bit more deeper into the business continuity solutions, learn how to protect our data, whether it's a planned event or an unplanned event. We'll take a break, and then when we come back from the break, we'll go into the performance. Before we start the session, I have a couple of things to share with you. The first thing being setting expectations. So if you are planning or looking to develop applications in Azure, or if you're looking to move your existing application to the cloud platform, this is an ideal session for you. It's expected that you have some basic understanding of the Azure platform, have some familiarity with relational database concepts and SQL. Also, please remember, if you're tracking your MVA points, this session gives you 50 credits. There's a code that you will need to enter. Please don't forget to do that. You have time until the end of October. And with that introduction, let's get started. Here's Bill, who's here to join us and talk about the overview. Bill, take it from here.
Hi, yes, I'm Bill Gibson. I'm a program manager in the SQL team. I've been at Microsoft for many years now, more years than I care to sort of recall. Most of that recently in the SQL Server group and SQL Database teams working on development and management tools. In fact, before that I was working in Visual Studio also on development and management tools. And indeed my early career has been in the sort of modeling and development tool space. So I've had probably something like 30 years now. Again, it's more years than I care to sort of remember working in this kind of space. So today I'm going to be giving you this overview session looking at Azure SQL Database and exploring several aspects of that. Take a look at what we're going to cover today. We're going to look at positioning the database service, and you'll see we position it in a continuum of SQL relational offerings from Microsoft. Then we'll look at the way we package and deliver the service as a set of service tiers. And then we'll look at the first of the two sort of topics that I'll cover an overview, but will be the main themes of the day: predictable and scalable performance, and then business continuity and disaster recovery. So these will be the bulk of the session there. So let's get started and talk about the positioning of Azure SQL Database. So we can't have that conversation, of course, without thinking about the cloud itself and why the cloud and what's the imperative here. Well, we see an absolute explosion at the moment of use of the public cloud, and increasingly now by larger organizations, not just smaller organizations and startups. So what's driving this? Well, there are three main drivers that we see. Speed, particularly the fact that in the cloud, we can now think about procuring and provisioning servers in minutes, as opposed to days or weeks. And that produces whole new opportunities for IT groups to support the business and to support developers. So that's tremendous. And then the whole question of scale, cloud scale. The idea that there is effectively limitless resources available to you in the cloud is huge. You don't need to worry about over-provisioning or under-provisioning, and that the elasticity of the cloud, allowing an application to grow and contract as the demand varies, is huge. And this drives a new set of economics that are relevant in the cloud. So now we have obviously this ability to scale applications up and down, to scale resources up and down, in itself produces cost savings. The fact that in the cloud you only pay for what you use. But beyond that, there's this opportunity to shift from a capital-intensive set of expenses and expenditure where you're paying upfront for investment in hardware and software, and you're paying for the administration and management of those resources. And you have to make those investments before you can deliver your application. So that's the world of the on-premise world of hardware. But in the cloud, we shift that now increasingly to a pay-as-you-go model, this elasticity, and now you're incurring expenses that are effectively operational expenses, so that you can pay the cost of your application as you start to see a benefit from it. So as you're earning revenue perhaps from your application, you're able to amortize the cost in that way. So that's huge. And the other thing is that with platform as a service and software as a service, increasingly you don't incur administration costs. There's no need to have an army of DBAs, as you'll see, to manage SQL database resources in the cloud.
So how should we think about Azure SQL Database within the cloud space? There's various Microsoft SQL offerings. How does that fit? Yeah,
well, it's a great segue to my slide here. So what we think here at Microsoft is of a relational database continuum that stretches from on-premise in what we refer to as our box product, SQL Server, all the way through to SQL Database up in the cloud. And in our box product, again, this is very much the space of tremendous control, tremendous power, but coming with the cost, if you will, of hardware and software investment up front. And as you scale across to the cloud or move across to the cloud, you shift from this sort of full control upfront investment model to this pay-as-you-go elastic scale low admin model of provisioning and managing your resources. And what's critical here is that Microsoft is sort of uniquely positioned, frankly, with offerings across this continuum. So we are able to not only serve you at each of these places in the cloud with infrastructure as a service running SQL Server in a VM, or platform as a service running SQL Database, but we're actually able to support hybrid scenarios where business solutions need to use potentially all of these offerings simultaneously. So that's a very exciting potential from using the Microsoft platform. So let's drill in on the cloud part of the story and try and help us understand the distinction between Azure SQL Database and running SQL Server in a virtual machine. So the key item here, key to mention here, is that with SQL Server in a virtual machine, you have SQL Server, you have the full power and feature set of SQL Server. You have full control, full flexibility to use all the features of that environment. It's highly customizable. By moving to the cloud, of course, you've eliminated hardware costs, so that's the huge benefit, the huge win. And for many people, because it's sort of business as usual working with SQL Server, it's the fastest way to the cloud. People can pick an application up and move it onto the cloud very rapidly. So contrast that with Azure SQL Database with its near zero administration sort of model. It's a fully managed service. It's a platform as a service, although we like to talk about it as database as a service. What's actually going on, of course, is you're buying databases. Instead of buying a server and configuring a server, you buy databases as you need them. You provision them, and you'll see me do that in a little while. So it eliminates the hardware costs and the software costs associated with running your own installation, and dramatically reduces the maintenance and administration costs. There's no need to now have, as I said before, a sort of army of DBAs managing even huge installations of databases. So that's very exciting.
Right. So the bottom line here is, if I'm looking to lift and shift an existing application, probably SQL Server and a VM is my best option. But if I'm looking to create a new cloud application, or if I want to move away from the administration costs and things like that, Azure SQL Database is probably the best bet.
Yeah, that's exactly right. Now you've exactly got it. So that's how we position and think about these two offerings. So let's now drill in. Today's going to be about the looking at Azure SQL Database. So let's drill in more and look at that. And let's look at key characteristics of this platform. So significantly here, and I've sort of touched on much of this idea of elastic scale and performance, the fact that you can start small and grow the database over time, add more databases. Performance and predictable performance particularly is critical, especially as you start to look at running business critical applications. The need to be able to predict the performance characteristics of an application is vital. And as we've talked about, the scale story, the ability to scale up and down is huge too. And with that, metrics and dashboards that provide you insight into the performance of your application, so you know when to scale up and down. So that's important. And then it's a robust and reliable platform. You'll hear more about this in later sessions. But we have an underlying high availability infrastructure which allows us to offer and back quite extraordinary uptime SLAs, service level agreements. So I'll talk about that more in a moment. And with that, we also have support for features like restoring a database, self-service restoring a database, and as you'll see, a range of options for provisioning geo-redundant copies of data so that your infrastructure, your applications could survive a major outage if that were to occur. And which, although none has ever occurred, it's often cited as one of the reasons why people perhaps are reluctant to step into the cloud. So you'll see we've made huge investments in that area. And then at the end of the day, it's still familiar to you. It's still SQL Server. It's still accessible to the same set of tools that you're used to using. So you can use SSMS and SSDT in Visual Studio and various third-party SQL development and management tools also can target the Azure platform. As you'll see, we have a full self-managed portal. You're able to manage the infrastructure, the databases yourself. And you can do this through our portal or through a set of APIs and PowerShell. So there's a tremendous flexibility for you to build your own application infrastructure over our APIs. So that was the positioning. That's how we think about Azure SQL Database all up. Let's look next at the service tiers and how we think about packaging and delivering the service to customers. So we've introduced recently over the last year, we've been introducing this set of service tiers, basic, standard, and premium. These are now generally available and fully supported. So with these, we have, for example, we've just increased the uptime SLA. It's now 99.99%. We've increased the maximum size supported for databases. That's now support for up to 500 gigabyte databases with our premium service tier. And then, as we'll touch on several times today, we have this kind of ongoing theme of predictability of performance. So, as I said before, the customers put high value in the ability to rely on the performance they can expect from the database. So they need that so they can run their businesses and their applications on our platform. And the way we think of that, of scaling this predictability across our service tiers, basic, standard, and premium, we think about basic offering predictable transaction rates measured on an hour-by-hour basis, whereas standard offers the same kind of level of predictability measured at a minute-by-minute basis. And premium, our highest level performance tier, set of performance tiers, offers predictability second by second and supports the highest transaction rates required of truly enterprise class, enterprise scale applications. And underneath this sort of predictability then is this idea of scaling and increasing the level of performance. So we have one level of performance with a basic database and then 3 levels of performance. And these scale up from basic through standard to premium. So 3 levels, and we have these names S0, S1, and S2 for standard, and P1 through P3 for premium. S0 there is our default. So if you don't specify the performance level when you create a standard, or even the service tier when you create a database, you'll get a standard database with an S0 performance level. And these performance levels and tiers are the basis of our pricing model. So we no longer price based on the size of the database. We price now on this performance that you can expect from the database, which is, of course, reflects very much the value you as a customer could expect to get from using the service offering. So our pricing goes from, at the moment, from something like $5 a month for a basic database to over $3,000 a month for a premium P3 database. And as you'll see, there's a huge range of performance difference between those to justify that high-end price there. And we've also changed our billing model. We've shifted to an hourly billing model now. And so, as we talk about scaling the performance of applications, the fact that you're billed by the hour means that your billing rate can track closely your changes in the performance and scaling of your application. So if you choose to scale down, you'll see an immediate benefit in the bill.
Or if I choose to make a copy for some reason, I need it for a couple of hours to look at something, I just get billed for those particular hours, correct?
That's exactly right, yes, exactly. You're no longer billed for an entire day. That's right. And then these next two lines here, these are our business continuity feature set here. And you can see again this scaling across the service tiers. Our restore is based on a backup model, and with basic, standard, and premium, we retain those backups for different periods of time. Basic for 7 days, standard for 14 days, and premium for 35 days. And then we can see a range of increasingly sophisticated sort of geo-redundancy disaster recovery options. And I'm going to talk about those in more detail. And you'll see that's going to be picked up by Sasha in indeed the next module. He'll spend a lot of time on this topic. So let's move on now. And so those are our service tiers, and the way we as I said, we package and provide the service. Let's talk about predictable and scalable performance. Here, I've touched on many of these themes before, but really I just want to pick up this idea of the way we measure and express performance. So we use a measure that we refer to as a DTU, a database throughput unit, and we use this to express the relative performance of these different tiers. So, Karthika, I know you and I have talked about this before. Do you remember what a DTU is?
Yeah, let me see. I think by definition, it's a blended measure based on CPU, memory, read and write rates that are made available to the database when I choose a performance level.
Yeah, absolutely.
And I think some people refer to it as a database's horsepower.
Yes, right? That's right. Yes, that's a good way of thinking about it. The amount of kind of oomph you give the database that will enable it to execute the workload. So if you have a large or complex workload, you may need to have a sort of more horsepower in the database to support that. If you have many more users, you want faster response time, and that's what you use. And as I say, we use this to express the relative performance of the performance levels and the service tiers. So if you look at, say, a standard S2 database, which has 50 DTUs, you can expect for any sort of a typical workload, a sort of average intensity workload, you might expect to see 10 times the throughput that you'd get from a basic database, which has only 5 DTUs. Go up to premium P1, and you'd expect to double that again at 100 DTUs. So that's the way to think about it. And talking about scaling up and down, one thing that's important to understand is we're not talking about sort of second-by-second scaling or minute-by-minute scaling as blips in performance occur. This is more about predicting performance requirements and scaling ahead, watching, for example, organic growth of an application and scaling to accommodate that. If, for example, at the end of the week or the end of the month, you expect to have more intense activity in your application, you can scale up to meet that demand and then scale down afterwards. If it's tax time, for example, you might, in some applications, have more intense an intense load. So you may monitor performance to make adjustments or predict this performance based on your own experience of your application. And critically is that the database stays online whilst you are scaling. So this activity, this change, doesn't impact your users. There may be just a brief dropped connections, which your application will pick up again immediately, in some cases when you make scaling changes. So that's predictable and scalable. So let's just switch over now and do a demo. What I'm going to do is show you some provisioning and scaling of databases. So I'm going to switch over to our management portal. So this is the management portal that's available to all users. I'm in the SQL Databases section of that, and I'm indeed looking at the moment at the list of databases. You can see I have some databases already provisioned. I can switch over and look at the servers. Servers are a logical grouping of databases which I use for administration purposes, and ultimately I create servers, create databases on a server. Servers are located in a region, and you can see that in the example here, I've actually used several different regions here. I've got databases in Asia, Europe, Japan, the US, and again in North Europe. So what I'm going to do is go and create a database, and I'm going to add another database, in fact, to this North Europe server here. So I'm going to click Add here, and actually I'm not going to do that. That's typical of me. I'm going to look at the databases. I would have added a server if I'd done that. So we go back to the databases list. And in fact, what I'm going to do is drill down on this server and then look at the databases on this server, which is pretty much the set we were looking at. So this, you can see now, these are all in North Europe. So now I'm going to go ahead and add a database. I'm going to give it a name. And call it MVA demo. You can see now where I can select the service tier. So as I said before, we default to a standard S0, but I could choose to provision a basic, a standard, or a premium. And if I pick any one of these, I can pick a different performance level. And you can see here the number of DTUs being prompted to me for each of these choices I'm making. And as I make these choices, I need to be conscious that I have a quota, actually, of DTUs that are available to me on the server, and I'll talk more about that in a moment. So you can see here there's over 1,300 DTUs available. All servers come with a default quota of 1,600 DTUs, which is enough to provision over 150 basic databases, for example. So I'm going to go ahead and create this database. And you can see back here on the list, it's going ahead and creating the database. It'll take just a moment or two to create this database. And when it's done, what I'm going to do is go back in and show you how I could scale that. Takes a moment there. I guess we're clipping over to Northern Europe. And sometimes it's worth just refreshing the screen here. Let's do that. I'll pull back up the dashboard there, and we can see actually there's MVA demo up here. The database is online, it's available, and it's a standard S0 database. If I click and go back in here, you can see how if I go to the Scale tab, now I could adjust the size of this database. I could scale it up or scale it down. And again, I've got the same simple option to go pick a different service tier and a different performance level. What I'm actually going to do is scale it down to basic, because I know that's going to happen very quickly. So I'll make a change here, and then I save the change. Save the change, and it will now reconfigure this database and reduce the horsepower that's being made available to this database. So I've created a database. What I can also do, and let me go to the dashboard for this database, is I can go and pick up the server name here, and I can use this name. So I'm looking at the server name there, and copy that, and I can take that and I can go into my favorite database development tool or management tool. In this case, it's SSMS. So let's make a connection to a database engine. In fact, I was connected to the server before, so that won't change. I need to provide my user ID and password.
So here we're using SQL Server authentication to connect to the database.
I'm sorry.
I said here we're using SQL Server authentication to connect to the database.
That's right. So that's the authentication model that Azure SQL Database uses. So it's connected to the database, connected to the server rather, and I can now go and get the list of databases, and you can see here's the MVA demo database we just created there. Let me just zoom in on that for a moment so you can see that. And I've got the full power of SSMS. I don't need to spend much time here, but for example, if I were to go, and we're SSMS is going to Azure, it's pulling back the schema information, and I can do, I can write queries. For example, I could open a query window here I'm going to open just a select on that database, and I could go ahead and execute this query. And really nothing special I want to show you about the query, just to show you that we've got the full environment of SSMS available to us. And if we go back now to the...
it goes back to using that familiar tools that you were talking about.
That's right. Okay, I'm going to shut this guy down. We come back here, and I go over to the server. And I just want to pick up here this idea of the DTU quota just briefly. So we've got this set of databases, now including the MVA demo. Each of them has a different edition and a different performance level, and they're consuming this quota of DTUs, of capacity, resource capacity that's made available to me. And if I go back to the dashboard, I can see that this particular server has used 235 DTUs spread across those databases of my available 1,600 DTUs. Okay, let's come back to the slides. So that was our provisioning and scaling story there. Let's move on and pick up the business continuity and disaster recovery topic now. I'm going to give you a summary of that. So this starts with our point-in-time restore capability. So I mentioned that briefly before. And with this, it's important to understand what's going on. We're taking backups of your database all the time. So your database is always protected. Those backups are moved into the cloud. So we're using Azure Storage to hold those. And the way you can think of this is that we're building this actually, it's another continuum, this set of backups over time, which you can use at any point. So if you have some incident occurs, it may be a human error or it may be a bug in a program which causes some corruption or deletion of data in a database, you can go back to any point in time and restore the database. We create another database, a new database alongside your existing database, which gives you the flexibility to choose to perhaps rename the database and fail over to this restored database if that's what you want, or to script data movement out of there to recover data, which is actually a very common scenario.
So it doesn't actually overwrite the existing database, it creates a whole new brand new database.
Exactly, and you'll see that pattern comes up several times as we go through, absolutely. And we keep these backups, as I said, for different periods of time, 7 days for basic, 14 days for standard, and 35 days for premium.
So you could potentially use this even to make a copy of the database, right?
Yes, you could. I mean, what's different, of course, is, and what's the opportunity here would be to make a copy from some moment in time of the database. Of course, if you use copy, that's sort of forward-looking, creates a copy that's current at the time the copy completes. Whereas with a restore, the copy you create is current with respect to the restore point that you pick when you restore it. But absolutely, you can do that. So there's a slight variation of this if we're restoring a deleted database. So if again, I have this look at this continuum of backups here that's available to me from any database. But if I delete a database, and of course at that point I'll stop paying for the database, we actually just retain the most recent state of the database in backup. We clear up this historical set of backups. And now as time goes by, this backup will sort of age, and you are free at any time within the retention period for the backup to go ahead and restore this database. So you can recover a deleted database in this way. And again, you recover from this. It's the final state of the database at the point it was deleted.
What happens if I delete the server?
Well, that's a great question, Karthika. If you delete a server, actually we're going to delete all the databases and all their backup information.
So I should be really careful.
Indeed, and you'll find that the act of deleting a server is treated very seriously in the platform. You have all sorts of checks and balances to make sure you really intend to do that. But indeed, you need to recognize that if you do delete the server, then you won't be able to recover the database after that. Then let's start looking at the first of our geo-redundancy options. So we have a range of options that scale across the service tiers, the first one of which is geo-restore. This is available on all the service tiers, basic, standard, and premium. And in this one, we produce a geo-redundant copy of the latest daily backup of the database. So it's not all backups that are copied. it's the daily backups. And we copy those again to Azure Storage, but now in a different region. So if there is an incident or a disaster, maybe a flood or something at a data center, never happened, don't worry about it, but if it were to happen, then you can go to these daily backups that are retained elsewhere, and you don't need to have access to the data center to recover from these backups. And you can restore a database. You'll be able to restore it to any region you choose at this point. But recognize that what you're restoring from is our most recent daily backup. So there could be as much as 24 hours data loss that could have been incurred as a result of that restoring that backup.
You said that this is available across all service tiers. Is there a charge for this?
That's a great question. So no, there's no charge for the backups. But we do charge, of course, just a normal database fee if you do restore from one of those backups. So if you create a database from this, then we'll charge the
hourly rate.
The normal hourly rate for the database thereafter. That's a great point. So then we go and look at the two replication-based geo redundancy options. We have two of these, standard georeplication and then active georeplication. And because we're using replication, there is, I'm not looking at a daily snapshot, but a continuous copy that's made, then there's the opportunity now to dramatically speed up recovery. We don't have to restore and create a database. There's a database in existence, and the data loss is dramatically reduced. We're not going back in time. The database, you'd only tend to have lost transactions that were still in flight, had not been replicated to the secondary at the point the disaster occurred. So it's a much better disaster recovery option. With standard georeplication, the secondary is offline, so it's not accessible to you. You can see that the secondary database. You need to have a server created for it. You'll see it on the server, but it'll be marked as offline, and you'll not be able to access that. And for that reason, there's a discount for this. So the database is charged at a discounted rate in standard georeplication. That's the secondary database is charged at a discounted rate. The secondary is created at in a paired region, so you don't get to choose where the secondary is created. And this makes a lot of sense here because this paired region is common for all across Azure. It's a system-defined region. So if you were to fail over websites or other components, other resources, then they'll all end up in the same place. So if you have co-located databases and websites, then after a failover, the same thing would happen. You'd have co-located websites and databases. And replication is asynchronous, so the performance of the secondary doesn't impact the performance of the primary. So having a secondary, having replication doesn't bottleneck or throttle your primary application. And failover, one characteristic of standard georeplication is that sort of in return for this having this discounted rate, failover is not enabled until effectively Microsoft has declared that there's an emergency, has declared that that a disaster has occurred, that we will not be able to recover the region in a reasonable time frame. And at that point, we enable this failover mechanism, and you'll then be able to activate the database. It'll become a full online read-write database, and now you can fail over your applications and make use of it as normal. So that's standard georeplication. Active georeplication builds on the same infrastructure, builds on the same technology. It's our fastest story, and it's our most flexible story. It's available in the premium service tier only. You have full self-service configuration and control of failover. So you can create up to 4 secondaries. These are now readable secondaries. They can be created anywhere in the globe, in any Azure region, although we still recommend using the paired region for the reasons I mentioned before. It's to encourage co-location.
Can you also create it in the same region if you want to use it for read load balancing?
Yeah, so that's a key a key sort of value proposition of active georeplication, is that you can use the secondaries to load balance read workloads, intensive read workloads, to take load off the database that's being updated, the primary database. And indeed, you don't have to put those into another region. You could be running in the same region. So if you have an intense set of different workloads, like reporting workloads, you don't want to interrupt your transactional update transaction workloads, then you can easily configure a readable secondary for that purpose.
Right. So I could have one secondary for disaster recovery purposes in a completely different region, whereas I can have another secondary where I'm using it for read workloads.
That's right. And what's more, you could choose to use an offline secondary for that disaster recovery. So if I add it here, and of course that will be constrained as to which region that can be in there. So I've added that fourth database there. Let me just show it there, which is the offline secondary, just as before.
Right. And for a premium database, now I have both these options available to me, right? I can have an offline secondary, and can I have up to, 3 now? Active secondaries?
Yes, that's
Is
right.
that how it works?
That's right. You can have a total of 4 secondaries, which if you choose to have an offline one, that counts towards that total. Okay, so that's the story around business continuity. Let's take a quick look at this in the tool, in the service. So let me go back to the service here. I'm going to go back to the my list of databases. And let's first of all look at what it would take to do point-in-time restore. So I'm going to go and look to one of the databases. Here we have, this is the AdventureWorks database. Here you can see some of the dashboard giving me access to metrics. But actually what I'm going to do now is go and trigger the restore option. And you can see here, this database hasn't existed for very long. Preparing for this demo, I didn't set things up sort of weeks in advance. But here we get a timeline where I can basically drag back over time here. Also, I can enter the restore point directly in this in the box down here. And I can enter this to the minute. So I can pick a specific minute I want to restore to. You can see that the database has been given a different name because, again, we're going to restore to the same server. So it must be a uniquely named database. So I can go pick this. It's midday UTC yesterday, I believe. So let's go ahead and set that restoring. So you can see it confirms for me that the restore is running. You can see it's doing that. And if I go back to my, let's go back to the, what am I going to do? I'm going to go back to the databases list. You can see down here there's the AdventureWorks database, the restoring version of it, and that's going to go on while we're talking here. The deleted databases, here I am, think of this as like a trash can of deleted databases. So I can look here, and in preparing for the demo, I've created and deleted quite a few databases. So you can see I've got various databases that I've got available to me, which these are ones for which we have backups available, and I could go and pick any one of these. I could go and pick this guy here and say restore, you can see I don't get to select the time now. The restore point is fixed at the point of deletion, so I could go ahead and restore that. I'm not going to bother. Then let's go again to our databases list, and what I'm going to do is look at the two the restore the geo-redundancy options now. So let's go look at I'm going to go look at a particular database here, and I'm going to look at the backups. And these backups here, this is effectively a list of available backups on this server, and this represents, so this is the geo-redundant backups I'm going to see here. These are the backups from which I could restore to another region. So there's been no disaster, I don't plan to do this, but I could go and pick any one of these now and restore it, and if I were to hit restore now, the significant thing is I can now choose a server. Again, there's no selection of the point in time I'm backing up from. It is that last daily backup, but I now get to choose a server anywhere in the world. Again, I need to think about the quota that's available on those servers, so I need to think about that and be prudent in the way I configure my environment. Okay, now let's go and take a look at the go back to the databases list and look at the replication options. So I'm going to pick first of all this database here, which is a standard database, and I go and take the look at the geo replication tab. Let's just zoom in on that so you can see that up there. select that. And you can see there's currently no replica set up for this. And it's a very simple click action. This is all it takes. This is what we mean by zero admin. I just come along and say, you know, I'd like to protect this. I'm going to go ahead and add a secondary. And because this is standard geo-replication, I'm only allowed an offline secondary, and here's the paired region, the West Europe region. This is currently in North Europe, so West Europe is the paired region here. I can get to choose a server here, so I have an available server. Let's go and use that, and I can go ahead and OK that. It asks me to confirm that this action, I understand this action is going to have a billing impact. Remember, I said that for standard geo-replication, there's a discounted rate for the secondary. Let's go ahead and OK that. And again, it confirms that it's successfully submitted the request and it's adding that secondary. And we can see here we can see that we now have a secondary set up here. Let me again zoom in on this. You can see it's an offline secondary. It's in West Europe, and we can see the information about it. And it's in a pending state because we're still setting up the environment. It would go from pending to seeding as it starts to copy the database. And once the database is completely copied, it's then in an active continuous copy mode.
And the status will show online?
No, it'll remain as offline. This is an offline secondary.
Offline secondary. That's right.
Yes, that's right.
It's only the active geo-replication that has the online status.
That's right. So let's go and take a look at a premium database and see active geo-replication in work. So here I go and look at the inventory management database, which I've configured as a premium database. And we can see that if I click on the scale, it's a premium P2 database. So if I go now to the geo-replication tab here, I get to set up my active secondaries now. In fact, I get to add secondaries, and I can choose whether they're offline or online, whether they're active or standard, if you will. But significantly now, because I'm in premium, I get to pick the region. So here again, we're recommending that paired region, but I can pick it from any of the regions. So let's go ahead and pick one of these, and now I can go ahead and choose a server. I happen to have a server already created in Japan, and create that. Again, there's a billing impact. With a readable secondary, you are charged the same price for the secondary as you are for the primary. And one point to note here is that the secondary must always have the same or higher performance level than the primary to ensure that replication to the secondary couldn't bottleneck or throttle the primary. And so I've added a secondary here, and I could go ahead and add a second one, or I can add up to 4, as we said. And furthermore, again, zoom in on these options at the bottom, I could go ahead and stop a secondary, and that would have the effect of making the secondary, instead of a secondary to my primary, it would make it an independent database. It would become, in effect, a primary database in its own right. So this is how I can control when I choose to fail over with this additional option. Okay, so that's the summary of our business continuity in DR story. We've looked through the kind of the characteristics and features there, and I've shown you demonstrations of that. And that sort of wraps up what I'm going to talk about in terms of introducing Azure SQL Database. So let's just maybe go back and just remind ourselves what I've talked about. This is our relational database as a service. Remember, you're creating databases as and when you need them. So it's in the class of platform as a service cloud offerings, and it particularly targets new cloud applications. That's what we were discussing earlier. It's a pay-as-you-go model with near zero admin. I think you've seen me. We've seen us looking at a backup model that's entirely automatic. We've seen how easy it is to set up geo-replication and to use sort of failover across geo regions. We have this tiered packaging model, these service tiers, basic, standard, and premium, the way we deliver the service. And we've spent a lot of time talking about, and we're going to spend more time today too, talking about predictable, scalable performance. And you've seen how I can scale performance. And you were introduced to the idea of a DTU, the database throughput unit, which we use as this relative measure of performance for the different performance levels. And I've talked about enterprise-grade SLAs, 99.99% uptime guarantee. It's Microsoft-backed SLA for all the editions, basic, standard, and premium. And then you've seen these rich business continuity features. So this scalable, predictable performance, robust SLAs and rich business continuity features for restoring or recovering in event of disaster. These are critical features for people thinking about, for customers thinking about moving business critical applications into the cloud. You need to look for these characteristics in the service. And then you've seen this sort of self-service dimension. You've seen how easy it is to use the portal. You've also seen how I can use familiar tools. I can use SSMS, SSDT. I didn't show you that, but that's the Visual Studio database development tool. So if you're familiar with that, it connects in just the same way. So there we go. That's the sort of overview, sort of whistle-stop tour of Azure SQL Database.
Thank you, Bill, for that great introduction. So with that, we're wrapping up this module. We're going to take a 15-minute break, and then when we come back, we'll go deeper into the business continuity solutions with Sasha. Thank you for joining us.
Thank you.
But that problem is sort of it's a wide range. It contains of several types of events. One is failures of local devices, essentially. Your servers, well, actually our servers deployed in data centers, network devices, media devices, etc. They fail. It's not often, but if you think about the scale at which we deploy the servers, thousands in each region, these events actually happen every day. The second type of problem is when you, as a customer, make an error. You make a mistake, and it happens all the time. You make a modification that is unwanted. You drop a table or sometimes even drop a whole database. And of course, the entire application is down as a result. So that is something that we do not recognize as a problem because it's a valid request, but you make a mistake and the application is impacted. The next set of problems is when a major event happens, a prolonged outage, some geographic events, or maybe some malicious act of a human. Usually these types of events impact the entire location or entire site, if you will, or a data center in which Azure SQL Database service is deployed. And finally, there is a set of events that we call planned events. They are usually required for both the platform, just like SQL Database platform, and the application itself. Things like patching, rolling out new versions, upgrading, adding features, or doing some other types of maintenance that sometimes is necessary. Those events very often very disruptive. You know about them ahead of time, you plan for them, but at the same time, you also need to make sure that when you do those events, your service continues to run. We are past the days when you can take downtime for several hours, even in the middle of the night, because it's a global world, and some customers of yours may be in the middle of the day when you're taking that downtime. So this is a set of events we also provide solutions and enable you to address. So let's talk about the offer. Let's talk about how the solutions that we provide actually included in the model that I believe Bill already covered in the previous module. So as you recall, we have 3 service tiers: basic, standard, and premium. And the main differentiation between those tiers is performance. So basic tier, we think about essentially something that allows you to perform transactions per hour. That's kind of the rate of change that is possible given the resources allocated in that tier. In the standard tiers, we are moving up to basically transactions per minute. You have more resources, you have a higher rate of change potentially. And finally, in the premium tier, where you have very significant resources allocated for your database, you can perform transactions per second. So this is important in our following conversation about how we essentially tier the solutions for business continuity. So first of all, if you recall the scenario where you make a mistake, we have a solution, we call it point-in-time restore. This is something that enables you to recognize an error and recover your database to a previous state where you know everything was good. In that state, you can continue to operate, or at least you can use that state to kind of recover the lost data. That solution is available in all tiers. We recognize that irrespective of how powerful or performant your database is, that problem could be devastating, and any type of application should be able to recover from it. The only difference, however, is that we provide a different retention policy in different tiers. For example, in basic tiers, we support 7 days of history, of transaction history, going back. In standard tiers, we increase it to 14 days, and finally, in the premium tiers, you can go all the way to 35 days back. The next solution we offer for business continuity space is called GeoRestore. This is the most basic and most sort of economical solution because it is included in every service tiers, and it doesn't add anything to your cost. You can always restore a database to a last daily backup that we maintain for you. So what it does essentially, if you or we as a service lost the entire region and the data is completely inaccessible or inaccessible for a long time, you can decide to restore the data to the last daily backup using that technology and run your application in different region. Now, the target recovery time and potential data loss is quite high. For example, because of the daily backup, you can lose up to 24 hours of data. And also the recovery time could be quite long, depending on the size of the database and the amount of restore operations being requested at the same time. But the good news is this is kind of free of charge. You can always use it and you don't have to pay for it until you restore, because when you restore, obviously you have to pay for that database. The next solution we offer is called standard geo-replication. That is a solution based on the notion of replicating databases and having sort of a standby copy of the database ready to go in case there is an error or failure and you'd like to fail over and continue operating on a new sort of primary database. This is a solution that included only in standard and premium tier, and B, every time you create a secondary database, obviously it increases your cost. There are some specific characteristics of this which I will cover later. And the final solution is called active geo-replication. It is only available in the premium tier, and it provides the most flexibility, most control to the customer. And it also allows you to support widest range of scenarios compared to the other solutions. So that's how we think about what we call BCDR model. Now, an interesting question, why, for example, we have sort of active geo-replication only available in premium and standard in 2 and the basic in all. The consideration here is the more capability of churning the data in the database you have as an application, the more potential data loss could occur in the case of a widespread loss of facility, widespread sort of outage. And of course, if you have a high rate of change, you need a more aggressive SLA. If you have lower rate, you may be able to kind of handle that case with a less aggressive SLA. However, if you consider the sort of the patterns in the application, you may have lower rate of updates and very high rate of reads, which means reads are not something you have to worry about in terms of data loss, but writes is. And if you have low rate of writes, even for a very powerful database, you may not need a very aggressive SLA, which is why we include sort of the lower level solutions in the higher level tiers. That's the kind of the foundation of the tier approach we use in the BCDR model. It's important to point out that the way we approach the recovery is that it is a very collaborative process. Some things we do as a service, and we guarantee it, and we make it as sort of automatic and transparent as possible. But at the same time, there are things that we expect you as a customer to do as well. So let's go over this. So as a service, we obviously provide it in a geo-distributed way, which means every region in which we have a data center provides all types of Azure capabilities and Azure assets. For example, if you are interested in web role or compute role and the database backup, those services are always available anywhere you go, independent of which country or which geographic area, etc. We maintain databases about our customers, about the subscriptions, about the servers you create, and this type of data is always redundant. It's centralized, but it is guaranteed to be recovered in a very short time in the case of total failure of the location in which this data is kept. You don't have to worry about it. There may be a little bit of a downtime in the form of inability to create new servers, but once you've created a server or you have a subscription already, you can operate on SQL database in the specific region you're using, no matter what. So this metadata will not sort of get in the way. The next one we provide is protection from this first, remember that first bucket, the blue screen case that I showed, where we may have some failures of servers or some devices inside of the data center. We call it a high availability scenario. That scenario is addressed automatically. You don't have to worry about it. It's transparent. All we are asking you to essentially have a retry logic in your application. Next one is backups. We maintain backups for every database we have automatically. You don't have to schedule anything. You don't have to configure anything. It's just done and happens for you, and it is not an extra cost or anything like that. If you chose one of those database replication solutions, and you've configured a primary and secondary pair, or maybe one primary and multiple secondaries, we guarantee that data is replicated automatically. It's a very simple operation, and I will show you later in the demo how it all set up. And we guarantee that replication happens with a very, very low latency. As a major service platform, we obviously are required to comply with a variety of industry standards, and all of those standards require us to perform compliance testing. We need to demonstrate to the auditors that our BCDR policy, BCDR planning is solid, it's verified, we can confirm the SLAs, etc. So we perform these tests regularly to comply with the standards. So it kind of gives you the confidence that as a service we're always ready and we always be there to protect your data. And finally, we also committed to informing you. If there is an incident in a particular region and it impacts your applications, we will provide information promptly about that, and we will guide you to perhaps perform a recovery or failover if you have geo-replicated configuration set up. So this is what we do. Now let's go over what you have to do in order for us collectively to sort of deal with the disasters at a large scale. What we are asking customers to do is, first of all, obviously, you need to recognize your own errors. If you make a mistake, if you drop a tape, if you make a change, and you know that the application is impacted, you have to take actions to quickly recover as quickly as possible, because the longer you wait, the more new data you accumulate potentially, and it will be harder for you to go back and sort of reconcile it with the lost data. Second, we expect you to plan ahead and prioritize your database in the case of a disaster. What I mean by that, you need to know, for example, where you're going to recover to, if, for example, you need to do that. If you're running your application in, let's say, Eastern US, you need to decide whether you want to recover in the West US or maybe some other area. So that needs to be happening sort of regularly, and also you have to know that up front. We also expect you to prioritize your deployments. We want you to think about the recovery as an emergency, and you obviously need to focus on the databases that are most critical to your business, and then focus perhaps on the rest later as time permits and capacity permits. Initiating the recovery operations, we provide a self-service API, scripting ability, also the support and portal, to invoke request operations such as database restore, geo-recovery, or failing over to a secondary database. And finally, just like we do our own compliance testing and drills, we expect you to do the same, whether it's driven by some standards you want to comply for confidence in your own service, or just because you want to be comfortable knowing that you are all set up for recovery in case of a disaster. We encourage people to do the DR testing, and we provide the facilities and ability to sort of simulate the unplanned events and test your application survivability, if you will, using the technologies that I'm covering in this module. So let's move along. This is my way to sort of position these solutions slightly differently and use the scenarios involved in the business continuity space vis-a-vis the BCDR technologies we include in different tiers. And you can see, for example, the majority of scenarios are supported in all tiers. They will have different SLAs when you use them, but you can at least make sure that those scenarios will be addressed. But there are some scenarios, specifically scenarios around application upgrades or application relocations without downtime, or load balancing of application for read access. Those scenarios are only possible in the premium tier if you decide to use Active GR application. So there is this value differentiation between the premium, significant value, I should say, significant value differentiation between the premium tier and basic and standard. So that's kind of also allows you to think about of importance of these scenarios. You know, for example, if your setup allows you to take downtime for application upgrade, you may think, okay, well, I can probably survive using a standard or even geo-restore solutions, because I really have this ability, flexibility, saying, okay, I'm going to take 5 hours down, and it's okay with my customers. But if not, then you may want to consider going to premium. So the next section here is discussion about the high availability platform. As I said, this is about making it transparent for you when we have failures of our own deployed servers or devices within the data center. Interesting observation about this space, as I mentioned earlier, that even though individual servers, for example, fail very, very infrequently, it's a rare event. But if you consider the scale, and again, thousands of servers, hundreds of routers, networking gear, media devices attached to servers, etc., at that scale, these events pretty much happen every day. Which is the reason why we believe strongly that recovery from these kinds of events has to be made automatic. We cannot expect you to be involved in making decisions and sort of invoking some sort of operations. It's automatic, end of story. So the way it works is when you connect to a database, it's actually it's a logical entity. It feels like a single database, but in reality, it has a set of databases behind it. We call it quorum. And those databases are all deployed inside of the same data center, but on different nodes. Absolutely guaranteed that you will never have these participant databases, physical databases, deploy on the same node. That is because we want to make sure that if the server fails, it will always only impact one of the replica databases in the quorum, not two or all. So basically in that configuration, you have a primary database and you have 2 or 3 sometimes, depending on the size of the database, secondaries. When you call your database with a read access type query, then you just immediately get a response from the primary and you move along. When you make a change, then we want to guarantee that the change is replicated and hardened, we call it hardened, on at least one of the secondaries. You had a question, Katrina?
Oh, I was just going to go back to that roles and responsibilities, where this one sounds like the service takes care of all the high availability. Probably the only thing as a customer that I need to look out for is when you make that change or when you fail over from the primary to the secondary, I would have to account for the retry logic, for example, in my application to make sure that momentary disconnect will be accounted for.
Yeah, that is exactly right. In fact, that's the only sort of way you can even guess that there will be or there has been a what we call reconfiguration or failover. You may see a very short downtime up to 30 seconds. And you may see a timeout, a disconnection, and you just need to retry the same connection or same query. And at that moment, essentially, it will be redirected. And let me actually show how it happens. So let's imagine this server failed. So obviously, you've lost connection to it. We have a Fabric, the platform that actually manages the service, and it recognizes the failure immediately because we have the watchdogs. We ping the servers, and all the neighbors will know, okay, well, that server has failed. So we have automatic machinery, if you will, that will make sure that immediately one of the secondaries that we know is still good and solid because it's all isolated is promoted. We make it a primary, new primary, and that new primary connects the other secondary. So at least we now have immediately two databases available. And then we immediately start building the missing third or fourth, depending on your database, replica. But of course, we need to redirect traffic from the primary we just lost to the new primary. And that kind of manipulation and reorganization of the quorum, if you will, takes a little bit of time. And that's why you're seeing these little bit of disconnection and downtime. But it's highly sort of watched, and we have a very strong sort of SLA saying that, you know, it should not take more than 30 seconds in the worst case. So that's basically how the high availability platform works. Now, there is a very important set of capabilities that we built in order to make it work. And the reason I'm calling this out is because this basically builds and becomes a foundation of all other business continuity solutions. So in order for us to pull this off, really, to make it automatic, we need to do a few things. First of all, we need to be able to create new replicas automatically. Sort of, hi, I need a database, I need a database on this node, let's just create it. Synchronize data. Every time you commit a transaction, data is synchronized and it's replicated to another secondary. Every database must be consistent. No matter what happens, whatever failure may take place, when we switch to a new primary, the integrity of that primary must be intact. Obviously, detecting failures is a key here, because we wouldn't be able to do any of this if you didn't know that it happened. And obviously, failover too. I mean, if you detect it and you decided to fail over, there needs to be a mechanism of doing that. At the end of the day, this is what allows us to have a very, very strong industry SLA of availability, 4 nines. It's pretty high. But more importantly, like I said, this architecture, this stack, if you will, has been in production for quite some time now. And it gave us very high confidence in using that stack for additional capabilities. So let's talk about those. The next session, I will cover the business continuity solutions based on database backup and restore. The first one, we talked about a bit already. It's point in time. It's recovery from your own error. What we do is every database, as it performs the transactions, commits, we take 3 types of backups. We take full backup every week. We take a daily backup, a differential backup, and we copy the transaction logs every 5 minutes. So that combination of backups, if you will, gives us the ability to essentially restore to a point in time.
Does that mean that I can restore granularity is actually only 5 minutes, or?
No, actually, this is a good question. The 5 minutes really should not be confused with the granularity. It's just a cycle of taking the copies of the transaction logs. But what happens if, for example, you set to kind of a specific point in time, what we do, we find the previous full backup, we restore the full backup to a database, then we go to the most recent differential backup, which is daily, apply that backup, and finally sort of play forward the transaction using the set of logs that we've copied, and find the precise moment which you specified and stop at that moment, which guarantees that we can restore to essentially any version of your database history, depending on what you like or when you detected the failure, and it's very precise. It's up to milliseconds. You can configure the restoration point. So the other thing that I'd like to call out here is the fact that out of these 3 types of backups, we copy full backups and the differential backups to geo-replicated, geo-redundant Azure storage. There is a fairly complex structure of containers we use, but more importantly, these containers are all protected because of the geo-redundancy that Azure Storage supports natively.
So there's a backup for the backup.
Essentially, yes, it's a backup for the backup, but this is why we are able to guarantee the data protection for every database, not just those you configure for data protection using replication, for example. So let's consider what happens. If, for example, you made a mistake and you impacted your database because now there is a table that is missing and the database application cannot work without it, you have to immediately recognize that, or as quickly as possible. Hopefully you have some protections built into your application logic itself. Once you've recognized that, you essentially call an API or go to portal and invoke the point-in-time restore action. And it basically takes few parameters from you, for example, the database name and point in time, and restores it. The restore will always be done inside of the same server. It's a side-by-side database with a different name. We never overwrite your existing database. The reason for that is because we don't know how you plan to use that new database. For example, if you detected the failure too late, you may have already accumulated significant amount of transactions, and you just need to recover one table, perhaps your application needs but is not critical. You can use that second database that we just restored to recover that table. But in some other cases, the data that you've destroyed is so critical that there's no way you even continue with the application. In that case, you may decide, okay, well, the restored copy is all I have, and I'm going to sort of redirect to it. So you will have to rename it, maybe delete or rename the original one that has been corrupted, and switch your application to the new one. So we created copy. We allow you to decide what is the next step. I mentioned the tiered policy already, 7, 14, 35. It's important because it sort of gives you a little bit more protection in terms of detecting the errors in case of higher end tiers. And it's all sort of programmable. You can use a REST API. You can call a script from a PowerShell. Or you can simply go to Portal and invoke this in the UI mode. And I will show that later in the demo. Moving on to GeoRestore. As you remember, I mentioned that we now have your database, the backup for the backup. And it's all protected because of the storage geo-replication. It's protected in a specific region. We have a strict policy about pairing the regions. So what happens is if, for example, there was an unplanned event that had very, very large impact and we lost the entire data center or maybe a set of clusters running Azure SQL databases, essentially you cannot connect anymore to your database. You can't see it. You cannot understand what happens. We will provide information. As I mentioned, one of our commitments is to give you that alert and tell you which servers are impacted. Once you got that information, the next step for you would be to restore that database. Again, I will show how it's done in the portal. You can also use the API. But essentially what you'll do is you will then call that API and specify where you would like to restore that database. It doesn't have to be in the paired region where the backup of the backup lives. You can choose any location in the world. The database will be restored to the last known daily backup. So you may lose up to 24 hours of data, of changes, but you will get your database back. That's what we call GeoRestore. And again, I want to stress this solution does not add any cost on an ongoing basis. Only when you restore that database, you will see that additional database on your bill.
So I can actually use this for my disaster recovery drills as well, right? Because this will be available to me even during normal times, not just when the region is down.
Yeah, exactly right. The reason we essentially open this API, and this API is always enabled, one of the reasons for that is because we want you to be able to test that solution anytime you need. So you don't have to wait for a disaster in order for you to test that your application can survive it. You can, on your own schedule, decide, okay, I'm going to test my application in that particular new region, make sure that I have all the configuration in place, all the artifacts, the application tier, the web tier, or whatever your application uses in that region. And when you restore the database, you can also test that the integrity of the application is intact and you can continue with your business. It gives you so much more confidence when you think about what might happen and the impact, the large impact that you will see in case of a major disaster. So yes, it's very easy to simulate or to create the sort of the workflow that will allow you to test your business continuity plan. One thing I want to call out, though, is that in this case, obviously, because you will be restoring to a different region and a different server, the database connection string will be different. So your application needs to be aware of that, and you need to design it in a way that when you fail over to that new database, when you restore it, the application recognizes the change that occurred because the server and the full URL of the server is now different. So that is one aspect, as a matter of fact, of testing. You need to make sure that your application has ability to recognize the new connection string. Let's move to the database replication. The first solution that is using that model or that technology is called standard geo-replication. Standard geo-replication allows you to configure a secondary database in a very specific region, and that region is the one that we use ourselves as a service as a DR pair. For example, East US using West US data center as a DR pair. North Central US uses South Central US as a DR pair. Same pairing has, is established in every geography, in Europe, in Asia, in Japan, in Australia, etc. So we have this pairing, and it's very well-defined policy. It is the same pairing that is used by Azure Storage for geo-replication, and we use that pairing. So what this solution allows you to do is to configure your database and select a server in that paired region to contain the secondary database. Once you've selected it, you call an API. It's very simple, and the database is created, and it will be there for you, replicating every transaction you commit on the primary. So the main difference between the GeoRestore solution that I showed before and this one is, well, not the main, but there are a few differences. One of the main differences is that it guarantees that the capacity in US West will be there for you when you need it. Because you've already created a secondary, you don't have to compete with anybody else. It's already pre-allocated for you. It's very fresh. It's been kept up to date automatically because that's what we do. So when you decide that you need to use this as a new primary, it'll be there no matter what. So this is a big advantage, because in the case of GeoRestore, you don't have the database. All you have a backup, and you need to restore the backup, and you need to get capacity to restore the backup. And imagine if thousands of people doing the same in the same region. So there might be a little bit of a competition for it. So this solution doesn't have that. You don't have to worry about capacity. And the second main difference, of course, is because it's a live replication of all transactions committed to the primary, your database is extremely fresh. So the SLA that you can enable this solution is much, much better than 24 hours that you have in the case of GeoRestore. So let's see. Let's imagine that you've lost the entire, or we've lost, I guess, the entire region, and you've lost your application in it. In this case, all you need to do is walk to the secondary and call an API or go to portal and say, I'd like to fail over. Once you failed over, that secondary becomes visible. You can redirect your application traffic to it. And at the same time, you must think about, okay, well, now I have my secondary, or primary rather, which used to be secondary. Now I need to protect it as well, because primary is gone. This is a new primary. I need it protected. At that time, we will most likely choose a different pair for this region, because we've just lost East US. So we will have to pick another one as a pair. Once we picked it, you can create your secondary database and continue to be protected. That is sort of the workflow. Essentially, you have to take these two actions. You have to fail over, and then you have to initiate additional new secondary.
Right. I have a question here. So I'm imagining the scenario where I have a primary in East US.
Yeah.
East, and my secondary is now in West US, correct?
Yes.
So East US goes down, I get a notification saying it's down, my primary is not available, and I have a choice whether to move to my secondary or wait until maybe you will fix it. Will I have any indication about that? How do I make that decision?
Yeah, so the way we think about this solution, we call it semi-automatic failover. The way we think about it is, first, you cannot fail over at any time you want. It's disabled in the normal circumstances. We only enable it when we know, based on all the telemetry, all the monitoring we have inside of the data center, we know that there is a major event and there is a major impact, large-scale impact on the customer databases. Only in that case we will say, okay, the failover is enabled. We will indicate the customers that the servers are degraded. But we don't force anyone to do anything. The customer has a choice, as you pointed out. One option is to fail over immediately. And the second option is to say, hey, maybe Microsoft will recover my databases in the East US. And in that case, I will have all my data back. Remember, we are talking about solutions, even in the best case with the very active live geo-replication, you still have a little bit of a lag. So there will be always some data loss because of the latency between the locations. So it's a very important consideration. And reason we are not doing this automatically, the main reason is because different applications have different tolerance to data loss. So to answer your question, your decision will depend exactly on that. It will depend on whether your application can tolerate data loss and you put a much higher premium to availability. If that is what you need, and you basically say, hey, I already tell everybody of my, all of my customers that there might be some data loss in the case of a disaster. It's part of my SLA. So I don't have to worry about, let's say, half an hour or an hour data loss. That's okay. But I do have to worry about availability. So I would rather fail over immediately as soon as Microsoft gives me that option and not wait for anything. On the other hand, I can imagine perhaps a small subset of application who would say, no, this data is so critical. I cannot take any chances. Even 1 second of data loss is devastating for me, for my business. Therefore, I'd rather be dark for a while and explain and apologize to my customers for the downtime than apologize for the data loss. I can imagine that sort of application as well. So those applications might decide, well, Microsoft is working hard on recovering the region. I will be better off waiting. Now, there's a caveat and a risk in that strategy as well, because what we do is we will try to recover, but if in 24 hours we conclude that it's unrecoverable, or the recovery will be so extensive, it will take so long time, there's no point for waiting anymore. We will force all the secondaries to become primaries. So essentially, you have this 23 hours between when it's between the enablement of the failover and the final call on recoverability of the region. And this is your sort of gamble, if you will. And again, if you wait for 24 hours, and we decided to fail, you will still have lost data, and you also will have lost 24 hours of availability.
Right. Sounds like a trade-off between high availability and data loss, and
yes,
your
exactly.
tolerance to all of this.
Yes, exactly. And this is really where only the application owner has the ability to understand the implications of these decisions and decide based on the business or the role of this application in the business, which is why we allow this kind of grace period for you to kind of make a call. You want to move on, you want to wait. If you wait, we'll still make you move on, so to speak, but only after all sort of options are exhausted, all possibility of recovery has been explored. So that's what a standard geo-replication is. It has about 2 hours RTO, and the reason it's 2 hours is because we will take about 1 hour to essentially troubleshoot and understand the impact and enable you to fail over. And then we assume you will have to run some checks, some validation checks to make sure that your application integrity is intact with the new primary, and that is how quickly you can recover. Like everything else, we provide three types of three ways of sort of requesting the self-service operations: REST API, PowerShell script, or portal. So you can choose whatever kind of suits your needs. And we provide some information via monitoring DMVs. You can understand some state of the replication. You can understand, for example, how far you're lagging. If there is a lag, you can see how, what is the last replicated transaction, and a few other things about replication, but not much. So especially in the standard case, when we provide a very concrete alert for you to kind of make the next move, then you really have to watch for that and sort of based on that information decide how you want to act. And there is a limitation in this case. The secondary, while it's being replicated, is offline in the sense that you cannot connect to it. You cannot query it. You cannot operate on it. It's just basically there as a standby to guarantee the capacity, as I said before. And you can only create one of those in this DR paired region. So this is kind of a limited kind of solution in that sense. Main observation is this is a solution that protects your application from our failures. If we fail as a service or Azure fails as a platform in that particular region, you are protected from that type of event. This is not to protect you from or enable you to do, let's say, online upgrades or some other sort of advanced scenario that I mentioned earlier. For that, you would have to go to Active Geo-Replication. So I said I believe that Active Geo-Replication is the most flexible tool, is the most flexible solution. You can have multiple secondaries. You can use those secondaries not just as backups, but also as a sort of load balancing option. You can connect to them. You can use them to fan out the information and to load balance your read access type requests. For example, if you want to build an application which accesses the same data in multiple regions to make sure that the clients are very close to the database backend, you can create multiple secondaries and use them as sort of parallel replicas for read-only access. You don't have to be constrained by our DR pairing. You can replicate anywhere in the world. You can choose different regions inside of the country, or you can use a different region even outside of the country. And in fact, in the demo, I will show you that. So it's very flexible. So when an event happens, let's say this is your primary database in South Central US, you will have to choose one of the secondaries. You have more than one to become primary. Let's say this is a West US secondary. You will have to basically, again, just like in the case of standard geo-replication, choose a new location to create a backup for you. And also you may have to create a new secondary for load balancing if you are using the load or supporting the load balancing scenarios. So you will have to kind of reconfigure your combination of databases after the failover. That's basically, it's very similar. It's the same API, same type of PowerShell commands, or a very similar experience in the portal between the standard geo-replication and active geo-replication. But active geo-replication, for example, is not constrained in terms of failover to when we conclude that there is an incident in the region. You can failover anytime you want. You can, for example, use that failover to, for example, create situation where you just want to move the database to a different region because your application is moving. Or maybe your application tier is failing over because there is major configuration mistake in the region and you need to move every VM that you're using or web role that you're using in your primary region to a different region. Database is totally fine. We don't see any problems at the database level. So we don't indicate we don't send any alerts, anything like that. It's your decision to fail over your application. And you want to keep your data tier in close proximity. So essentially that means, you can do that. You can kind of move the database backend along with the application using active geo-replication. It is not possible in other solutions. So that is basically what I wanted to tell you about the technologies, and I'd like to move to the demo at this point. So let me tell you about the demo. I'm gonna remote to my desktop. Let me do that. I need to reconnect. So here's what I have. Let me remove this. I have a database and I have 3 servers that I have created ahead of time. One is in Brazil, one is in the East US, and one in the Southeast Asia. In East US, I have my primary database, or actually I have two databases. One is the premium database, which I will be using to show you the geo-replication technology. And the other one is a basic demo database, which is the one I will show you, the backup-based solution. So first of all, if I go to my premium database, you can see that there is a step called geo-replication. It's a premium database, so I can essentially configure it for geo-replication at any time. And it now shows that there is no secondaries. It's empty. It's just one database standalone in the East US region. What I can do now is I can decide to add secondary. And when I click on Add Secondary, there is this option of offline or online. Offline refers to the standard geo-replication, and online refers to the active geo-replication. So I choose online because I want to show you the most sort of flexible solution. I need to select which region I want to use. In the standard case, this region will be fixed for me. But here I have flexibility of choosing any region in the world. So let me choose something really, really far away. I'm going to choose Southeast Asia, because I know I have a server there. I pre-configured that server there. But it's important because I want to show you the replication in the case of very long distance, which means latency for the signal. There's laws of physics involved here. So I'm going to choose a server, and I have one only. This is a server I've got in Southeast Asia. That's where I'm going to create my secondary. So think about it. I have a primary running in East US, and the secondary will be created in Singapore. So I'm going to click yes, and this is basically just to confirm that I'm willing to pay the price for the secondary, which will be another premium database. So now immediately it starts creating the secondary, and in pretty soon it will have created it. If I go to the databases now, I can see that secondary. That list will be updated as soon as that secondary is created. As you can see right now, it's saying it's pending. It's still working on it, but the database has already been registered in Singapore, and we're going to wait until it's fully instantiated. In the meantime, I'd like to show you how the backup solutions actually work. So if I go to my basic database, you can see that there is this restore button at the end of it, at the end of the screen, at the bottom of the screen. And let's imagine that I've been using that database and I made a mistake. I dropped a table yesterday. So as you can see, and when I click restore, it allows me to specify the new database name, and I'd like to change it. It shows, by default, it simply attaches the timestamp, but I'm going to call it restored. And it also allows me to specify the point in time. And there are two ways I can use the slider and just do it like this. Or I can simply type the specific date I want. So let's say yesterday at 12:01. I know that I made a mistake at 12:02, but I want to get as fresh a version, or the most closest version to that particular set event that I created myself. So I'm going to create essentially a restored copy of this database, and it's going to restore it in the same server. So this is going to continue. And I also would like to show you what happens in case we decided to use a geo-restore. So it's created, it is creating the sort of point-in-time restore copy. But imagine we've completely lost US East region, and you need to restore that database. How does that work? That is actually different, because now you cannot go to this database in a live mode because you cannot connect to it. It doesn't exist anymore. So you have to go to the list of servers. So if I go to the list of my servers, I know that I have this server in East West, and I know that I just got an alert from Microsoft showing that this server is degraded. But I need the database back. I need to continue running my business. So what I'll do is I go to this server, and it will show degraded. And you can see this tab called Backups. If I click on it, instead of showing me the live databases, it essentially shows me the databases that I used to have in that server. And if I pick that one, which is the one that I was using in production, I can restore it. So this is restored directly from the geo-replicated storage. When I click Restore, it allows me to restore anywhere I want. Let's say I want to restore in Brazil. It's far away, but I feel like there is little competition in Brazil for restoring these databases. I can choose that, and it also shows me the last daily backup. So I know how stale my database is. Arguably, in the case of disaster, it's not like I have a choice. I still have to restore it, but at least I have the information that this database is relatively fresh or maybe not as fresh. And I start restore, and it'll be restoring that database in Brazil. So that's kind of how you invoke it. Now, the length of the restoration obviously depends on how big your database is, and also, as I mentioned earlier, how many other people at the same time trying to restore their databases in that same region. Now, the way we prioritize the restore operation is to make sure that as we run these restores, we do not impact the performance and availability of existing tenants in that same region. So we absolutely must make sure that when people start restoring the massive amounts of data in this region, the existing customers with their live databases can still do their job. Now, let's go back to see what happened with my geo-replicated database. As you can see now, I have the secondary, and if it's too small, I can actually make it bigger a little bit. So I have this secondary. It shows online, premium database, and it's Southeast Asia. And that secondary is sort of now is my backup in case of disaster. And what I'll do next is I will show what happens with transaction as I commit them. So I have two, this is Management Studio, I have two connections. The source connection is to the primary database in East US, and the target connection is to my secondary database in Singapore. So what I'll do is, this query essentially creates a set of transactions, pretty complex join. Every insert really is 729 rows, and I will run 5 of those just for demonstration purposes. And every time I insert, I will run the second query on the target to see how quickly those sort of rows show up on the target. So let's do that. First of all, let me just make sure that I'm connected here. Yeah, so this database is empty, and I'm gonna run this, and same here, just to make sure that connection is live. Yeah, connection is live. So I'm gonna run this query, and it's gonna show me transaction. I'm gonna run the same, not same, but query that sort of recognizes the new rows in the table. As you can see, it inserts these essentially batches of 725 rows. And I'd like to bring your attention to the time. So you can see the difference when transaction has been committed and transaction has been recognized on the other side. We're talking about seconds difference. Essentially, from 1 to 2 seconds difference. This is how fast this replication transfers the data between East US and Singapore, and those transactions are replicated on the target, and you can see them, and you can use them, you can read them. And again, I stressed before, and I want to repeat, this database has the same integrity, same transactional consistency as a source database. So even though it may be lagging a little bit behind, maybe by a matter of seconds, it has full consistency inside. You can run the same code against it as against the primary. So now we've replicated the database, and again, the last one, see 5953 and 5955 is when the same data showed up in Singapore. So that is kind of the freshness and speed of the replication. And imagine we're talking about the other side of the world. So the connection is very, very long, and yet the replication happens extremely fast. That is pretty much all I wanted to show in my demo. Perhaps one other thing that I would like to demonstrate is how I can actually fail over. So if I go to my secondary in Asia, in Singapore, again, I go to the geo-replication tab, and you can see this action at the bottom called stop secondary. And that essentially how I decide that, okay, I'm going to essentially convert that database into my new primary, and once I've converted that database, it'll become writable. While it's a secondary, it's not writable. I can only read from it. And that's what I can do. And there is this option to stop replication immediately. Essentially, it means that I'm going to ignore whatever happening on the primary side. I'm going to just move on right away without waiting anything. And again, this operation starts after it's finished, and it's metadata change. It's not copying anything. It's just changing the state of the database. Once it's done, you can redirect the user traffic to this database, and this is what failover is all about. So let me go back to my deck, and perhaps there is only one. Actually, there's no more slides there. This is the end of this module. I hope it made it a little bit more clear and interesting, the solution we offer for business continuity. And I'd really like to encourage you to start experimenting with that. It's available in production today. We have officially went we went to the GA mode with these capabilities in September. So it's open for business, so to speak. Thank you very much.
Thank you, Sasha, for that great session. I really like to see that active geo-replication in action.
Yes, you're welcome.
Okay, so we're now going to take a meal break, and we'll return probably in about an hour or maybe the top of the hour. Hello and welcome back to the afternoon session of Azure SQL Database. We have two modules this afternoon. The first one, Jan is going to start us off and talk about predictable performance. Jan?
Hello, Karthika. Thanks for having me. My name is Jan Engelsberg. I'm a program manager in SQL Database. I joined Microsoft about 4 years ago and came straight from Germany. And I've ever since been working in SQL Database, originally focusing on the T-SQL surface area, and in the recent 2 years been working on predictable performance, which I will be talking about.
Great, thank you.
All right, let's get us started. Predictable performance. I have 4 things that I would like to talk about and shine some light on them. The first one is the case for change. So why did we introduce those new service tiers? The second one is talk about concepts. So what does this predictable performance mean? What are the concepts behind this? I'll go a little bit into how to choose performance level, which one is the right for you. And finally, I'll be talking a little bit about quota management, which Bill already mentioned in the morning. I hope I can add a little bit to this one. So let's jump into it.
Let's jump into it. Please tell us why the new service tiers.
Be more than happy to. Case for change. What we hear from our customers since we started SQL Database is that the unpredictability in performance, and this means you get a varying throughput when you run your workload, is a big challenge for a lot of customers. And we took this feedback and looked into what can we do about it. And to give a little bit more background on this one, I'm gonna explain a little bit on how web and business databases that we had up until this point worked and what the difference is to the new service tiers. So in web and business, what you get is for your money is essentially the storage that we provide to store your data. So in this concept, we didn't make any promises around performance, and it would really be you get as much performance as we can give you at any given point in time. However, depending on what is going on, you might not actually get this performance. Another thing, and because of this, right, because of we can't really predict workloads of databases, because of this, what can happen is that machines become overloaded, and then things, what is very well known as throttling would happen, which is we have to stop connections and stop workloads from running, or not accept new workloads too. One thing is to protect other customers, and the other thing is to protect the system from being overloaded. Because of this, performance, as I said, can be very varying, and this is just bad experience. If you need the performance to be predictable, obviously it's very tough for you. So what we did is we deprecated the web and business databases, and they will be running until September 2015. And we introduced the new basic, standard, and premium service tiers. Premium has been introduced a while back already in a public preview. And what we do there is we switch from a model where you used to pay for storage. We now switch to you pay for performance and a set of features. And you don't pay for the storage anymore. With this new concept, we changed from this approach of throttling to an approach that we call resource governance, and I'll be talking about this at a later point in this session, what this means and what this does. And with this resource governance mechanism, we bring in way more predictability into the system, meaning when you run your workload, you can actually count on it. The new additions, as we might have mentioned, are generally available since this month. And they're fully backwards compatible with one small exception, which is federations. Yeah, so this is really the change. This is why we made the change, because customers actually asked for it.
Yeah. So since customers asked for it, what did we do to resolve that problem that you first talked about that exists in the web and business tier, or existed in the web and business tiers?
Excellent question. So when you look at how the system works and how the system is set up today, or generally is set up and used to be set up, on the left-hand side on the slide, you can see how web and business databases used to work. And I'll show you on the right-hand side how we now run those. So if you look at web and business, what really happens is you have a set of workloads that run on a machine, and they all, like, we pack them together so that they seem to be working out. And right now you can see, like, yeah, everybody gets something of it, and it's fine for the databases. However, if one database all of a sudden increases the load significantly, what will happen is this database will take over a lot of resources on the machine and taking those resources away from the other databases that run on the machine as well. And this is exactly what people know as the noisy neighbor problem that we have in the system. So ultimately, yeah, what happens, one guy takes over and your workload doesn't get any of the resources anymore.
And then I could see that throttling as well.
Exactly. And so in these kind of cases, there were two sorts of throttling. One was soft throttling and one was hard throttling. In the soft throttling case, we would try to stop this heavy utilizer from consuming all the resources. And the hard throttling case would be, hey, the system actually is so overloaded that we need to protect the node and stop this from happening. So to overcome this problem, what we do is we introduce bounding boxes. And this is, when we talked about premium, this is exactly the concept behind it. So what we do is we carve out capacity on a machine and run the workload in it. And this has the effect that you don't run into these noisy neighbor issues anymore. So if you look at the graphic, you can see each of those workloads that were on the left-hand side before are now contained in one of those boxes. And if you look at the DB4 workload, now if this one tries to expand, it will get stopped and governed within this box, and it can't impact the other databases on the node anymore. And this is the concept behind it.
Yeah, that's great. But it sounds like this is quite a big change. Is there any customer impact to this on how I should think about it now?
Yes, this certainly does have impact for the customer. There are some changes in responsibilities, I would say, if you look at running a database. So from a SQL database side, what we are doing is we try to guarantee you a set of resources, and we try to make sure that whenever you request those resources, that they are available to you. This is certainly lies in our responsibility. The other thing that we from a SQL database side are doing and are trying to doing and getting better at is giving you insights into your own workload and how many resources the workload consumes. And then on top of that, obviously, with making a change reasonably big like that, we have to educate people on how to use this, which is, I guess, one of the reasons why we're here today. And I hope we've been doing a good job so far, and I will do a good job in that. From a customer perspective, there are really like two things to consider. One is, what is the feature set that you would like to have when running your database? And we saw the business continuity feature set and how this is distinguished between the different service tiers. The next set of things that you need to look into is what performance level does your database need to run predictable and run at an acceptable throughput. And then the last thing that falls now into the responsibility of customers is to monitor the workload, their own workload, and make sure that they remain within the limits of this performance level that they chose. So this is kind of like a shift when compared to before, where web and business databases, essentially the difference was how much storage do you get, and everything else, well, was essentially the same, and performance was equally unpredictable amongst those two. And yeah, so there's a shift in the sense that customers need to pay a little more attention to detail and figure some things out. But yeah, as I mentioned earlier, we had the overwhelming feedback that the unpredictability is a problem, and this is how we're going to solve it.
Yeah, in the previous world, there was nothing much I could do as a customer when I got unpredictable performance, but now I have more control, more predictable performance, if you will. Yeah, that's great. Yeah, so with that, can we jump right into concepts in the spirit of giving more guidance? And maybe you can talk a little bit about this DTUs that we've been hearing all morning.
Absolutely. Yeah, looking at the concept. So on the previous slide, you saw actually the one before, you saw the concept of a bounding box. And I already mentioned that we essentially carve out a set of resources that are available to a database. And the resources that we carve out are compute resources, so effectively CPU, log writes, reads from the data file, and obviously memory that you need to run your database. So those are the four resources that are the most critical for a database, and those ones we combine together in these bounding boxes, and we label these bounding boxes with a number that is the database throughput unit. So you might ask, why are we doing this? Why are we not saying, well, how much CPU do I get? The reason for that is we want to abstract from the actual physical resources that are needed, which gives us the flexibility to actually make changes in the system while maintaining a certain amount of power that you get. So we will assure whenever something is called 50 DTU that you will always get the same power, no matter if we made a change in the underlying software. If we change the hardware, 50 DTUs will always be 50 DTUs, and you can rely on this. The number itself will let you compare the different performance levels to each other. So if you look at a standard 2 database, for example, that has 50 DTUs, you can compare it to a P1 database, a premium P1 database, it has 100 DTUs, and it has double the power to run your workload. This said, the power is determined by a benchmark that we have developed and that we use to measure how much throughput does a workload get against our new additions. Charles will be coming in later to talk more about the benchmark. I will give a very brief introduction on the next slide to it. But we run this workload, and if you go back to the example of an S2 versus a P1, what we do is we run the workload against the P1, and it generates a certain amount of throughput, and you will see the numbers later on. And then we run it against an S2, and there we'll actually produce roughly half of the throughput. And this is how we determine the DTU number. And we use this benchmark to keep those numbers stable no matter what we do to the system beneath. And so lastly, what we're doing is we give you a percentage on the monitoring side of things with regards to the 4 dimensions that make the bounding box. The reason for that is, given that we don't give you an actual resource or the underlying resource numbers, we need to give you some idea of where you stand with your workload. And yeah, you will know, hey, I'm at 50% of CPU, and this is what those percentages are used for. And it makes the conversation obviously way easier when we talk about, well, what is an IOP, right? Or what does 50 IOPS mean? Well, if you know you have 50% of your bounding box, well, that is a statement you can work with and make hopefully an educated guess on where you should go. So much on the DTU. As I just mentioned, the Azure SQL Database benchmark, Charles will be doing a deep dive session on this one right after my session, so I'm not going to talk too much about it. But it's an example workload representing a meaningful OLTP workload. There's a mix of varying size tables, and we run different types of transactions. And this, like how benchmarks work, determines a throughput number, which we use to set those DTU levels. And again, Charles will be doing this in way more detail, so I don't need to cover this in more depth here. All right. So looking at the bounding boxes, I talked about throttling before, and this was certainly a pain point for our customers. So using this concept to keep people within their resource boundaries is not a very good experience, because simply you will get an error message and things stop working. We switched to a different model that we call resource governance, and I'll explain how this works. So within the SQL database, we have a governor that governs a CPU, writes to the log files and reads from the data file. And memory works slightly different because it's not like a streaming resource. But how this works for these 3 streaming resources is whenever you do queries against your database, and in this case we have 4, these queries need resources to be executed within the SQL database. And what we do is we queue the resources, or we put the requests into a queue for each of those dimensions. And whenever nothing is running with regards to your database, whenever essentially the resource is idle, we will let things go through, and we will produce a result. So we queue the resources and go one after another and work through them, and this will let the database produce a result. So now, if you compare like an S2 database to an P1 database, the difference there is that the governor will let more resources go through at the same time. So essentially, you send your 4 queries into the system, the resources get queued up again. However, when the workload actually runs, more resources can go through the governor, and the results are being produced faster. One thing to be a little cautious about is if you put a lot of workload against your database, so it's essentially when you are your somewhat own noisy neighbor, We will not terminate any of the queries. We will accept them, we will run them. However, things will slow down, as they would if you think about having a small computer where you run a database under your desk, right? If you run a tier 1 workload against this one, well, the machine will reach the limits and things will slow down. The effect of this is you might see query timeouts depending on the timeout that you have set on your client, and the default is 30 seconds. So if you see timeouts, a thing to look into is increasing this timeout. And the other thing that can happen, and this happens in the system today, and people are probably aware of it, you can run out of worker threads in SQL Database. A worker thread, you can think of each request that comes into a database will get assigned a worker thread, and the amount of worker threads per database is limited. This information is public, or is published on our documentation websites, but this is simply something to look out for. So if you overload the machine, the requests will get queued up. Given that we can't process them fast enough, you will run out of worker threads, and in this case, you will still get an error message. So this is just something to look out for. But the concept, as I mentioned, is different from throttling itself. So resources are being queued, you get slowed down whenever you reach your max, and we will process it as fast as possible according to your performance and according to your performance level. However, look out for those two things.
Yeah, so how do I know I'm going to hit my limit? When I'm, getting up there, I'm using too much CPU, or, I'm getting one of those limits, and how should I think about, how would I know that I need to now actually rethink where I am and probably move up?
Yeah, excellent question. And this goes back to what I said earlier, where customers gain a new responsibility in monitoring their own database and making sure that their workload stays within the limits. We have had this for a while. We have DMVs that will show you how many resources you use, and there are two of them today. One is in master, and this has been around for some time, which is called sys.resource-stats. This view shows you your utilization in percent, as I described earlier, for CPU, log writes, and data reads. This view shows you averages. Oh, sorry about that. Shows you averages over 5 minutes. So this is a little bit tricky to use because if you have a workload that spikes once in a while and spikes reasonably high, then averaging out is it's somewhat tricky to use, right? So if you just make an example, the first 2.5 minutes you run at 100%, whereas the second 2.5 minutes you don't do anything. Well, this view would show you 50% utilization, whereas really you had 100% at some point in time and you maxed out. Mm-hmm. To overcome some of these difficulties, we introduced the second view recently in the user database itself, so not in Logical Master, but in the user database. And this one is called sys.dm_db_resource_stats. So it follows our usual naming convention. And this view shows you your utilization based on 15-second granular data. Here again, these are averages, and we would like to provide you even finer granular data, but compared to the 5 minutes that we have so far, this is a big improvement. And so when looking at this data, you get way better insights into how spiky is your workload and when do you reach what limits. So certainly in monitoring your database, this is the better view to look into, and you get only 1 hour of history in this view because it is kept in memory within the database. However, after this 1 hour, this is roughly where the resource stats lag is. So after the 1 hour, you can think of it as being rolled up into those 5-minute averages, and you can see a more historical view in the sys.resource-stats in master.
Yeah, so these views are related specifically to Azure SQL Database, right? These DMVs. Right.
Yeah.
Yeah. So I was going to ask you if there are DMVs that typically are available for SQL Server on the box that could be useful here.
Yeah. So first of all, yes, it is correct. Those two views are specific to SQL Database. What is also correct is that other views are available to look at your workload. So, for example, wait stats as a typical thing that people use to debug workloads in SQL Server, and wait stats is available in the user database as well. And we have documentation on all the views that are available in SQL Database. It is not yet the full set that is available in the on-premise installations or in the software, in the infrastructure as a service SQL Server, where you run a full installation essentially. But we're working on improving this further and expose more of those DMVs to give you more, tools essentially to debug your workloads. But the essential stuff is there, and the resource consumption specifically, because obviously you don't have access to a machine to look at a perf monitor. So this is why we introduced those two views in SQL Azure specifically. As I mentioned, those two views show percentages. One other thing, and I'll show this in a demo later on, is those are available through the portal. In the current portal, only the sys.resource stats, so the averages over 5 minutes, is available. In the next version of the portal, the more real-time and more granular data will be available in the portal as well. One cool thing in the portal is you can set up alerts for those resources, and I'll also show this how this works. Basically, the idea is, well, you can't always monitor yourself what does your database do at any given point in time. However, we have this data, and you can set up an email alert that notifies you, hey, my database has been running hot for the last hour. You know, maybe I need to take a look into it. So we allow you to set up alerts on this.
So I got the concepts, but I have an application now. Where do I start? How do I choose a performance level? Or maybe I have an on-premise application that I'm thinking of moving to the cloud. What information can I use, or how do I make that call, which performance level and service tier I should go to?
So the guidance for migrations from on-premise so far is, well, you really have to test. Because it is very hard to compare. Well, we don't know what hardware do you have. You don't know what hardware do we have. You can look at how does our benchmark work to get an idea, and you can certainly look at our documentation and see, hey, you know, my database is like, it's reasonably small. I use it once or twice a day, right? I do a handful of transactions, so maybe the lower service tiers or the lower performance levels will work for you. Whereas if you have like a, hey, you know, you run a website that gets reasonable traffic, or you have a line of business application, these kind of things, then probably you need to be somewhere in the mid-range. Well, if you run an enterprise grade application, then probably the premium performance levels are the right ones for you. Generally, what we advise people to do is, well, take your workload, test it, see where you are, and then make a decision based on the results that you see from our utilization views. If you already have a web and business database today, you can make an assessment of where you are with regards to your resource consumption. If you look at the view that I mentioned earlier in master, which is sys.resource stats. So there, given that web and business databases don't have this container, they don't have a DTU assigned to it. However, we give you some insights into your workload by showing you a percentage where you stand relative to an S2 performance level on each of those dimensions. So to make a concrete example, you run this query and you look at CPU and it shows you 50%. Well, this means that you are at 50% of the CPU power that an S2 database gets. This view might show you 200%, which means, hey, you actually exceed those limits of an S2 database, and hence probably S2 wouldn't be the starting point for your workload. And obviously, yeah, there are these constraints that I mentioned earlier, that this view is over 5 minutes and these are averages. So you have to be a little careful on making those assessments. And I also would strongly recommend do test first. Because moving a production workload into a database and you get a little bit stuck is obviously a bad experience. So do definitely test first and see where you stand. But this view will give you some insights. And we have a great blog post out there that explains on how to do this sizing and do a first estimation on where your web and business database is to move it into the new service tiers. When you want to switch between service tiers, so essentially you do your testing and you run your application and you see, well, I'm at 50% overall, or I get close to 100%. In these kind of cases, you should use the sys.dmdb resource stats in the user database to get a good feeling of where do you actually stand, to get as the highest granularity that we offer. And then you can make a decision based on where you stand overall. So for example, if you run in a P1 premium database and you see all your resources are always only at 25%, well, maybe then you don't need the performance, right? And maybe you can actually go down to an S2 database, assuming that you don't need the premium feature set, obviously. Again, the blog post that we have out there and that I think is in the resources that we show here gives you information on how to do this, shows you some queries that you can use. One big thing that with these no service tiers, people will have to look into as query performance tuning or query tuning on up. And it goes in the direction, Karthika, what you asked about earlier. Are other views available? Yes, they are. Some of them are listed here on the slide, like DMXI query stats, DMXI query SQL text, and so on. So we strongly encourage people with this switch to these bounded performance levels to look into these things again. Like you can imagine in web and business, this was kind of like a secondary thing, other than if you were impacted by noisy neighbors, then you would obviously look into, hey, how do I make my database perform better? But now with these restricted performance levels, you can even benefit from optimizing your queries, optimizing your workload, and maybe even bring it down and into a lower service level. One last point that I would like to make is, if you look at the life cycle of a database, right? There's normally, you have the creation, you probably have the initial population of data, then you have a regular workload that runs in your daily business. You can have maintenance operations going on. So for example, think of recreating indexes. These kind of things. These are all different segments of your life cycle, if you wish, of your database. And so it is probably worth looking into running these different segments in different performance levels. So if you are, for example, if you have an application pattern that requires you importing data and populating data, I don't know, let's say every 2 days, right? Maybe it is worth it to actually up the performance level for the period of the import to make this a faster experience. Whereas your regular workload, right, when your regular queries run against your database, maybe a lower performance level is sufficient there. And we switched with the general availability of these service tiers, we switched to an hourly billing model. And so it is certainly worth it looking into this. Because you can optimize, right? You don't actually need to size your database initially for one of those peaks, but you can change the performance level to get sufficient performance to fulfill this peak. Obviously, this requires a somewhat predictable workload. But again, if you do maintenance operations, for example, on the weekend, then yeah, up your performance level, let it run through quickly, make sure that your regular workload is not impacted by this maintenance operation. Once it's done, go back to the lower performance level and run there for your regular
and also
workload.
Similarly, if you have a month-end operation that you have to do regularly, that takes a lot of, workload. It goes up. You can do that as well. So at the end of the month, you go up and then come back down again.
Exactly.
Yeah.
Exactly. This is exactly one of those scenarios. Yeah. So it's not only the cycles in your application with regards to like maintenance and these kind of things, but obviously if your workload varies like this.
Business needs.
Business needs. Very good example.
Yep.
Very good example. So how does this changing of performance levels work? I'm sure Bill showed this in the portal earlier already, how easy it is. And this is an online operation. I assume he mentioned this one as well. So your database will not go offline when you change a performance level. This is an operation you started, it happens asynchronously, and it finishes at some point. And then in the absolute worst case, you might have a small disconnect, kind of like how you have it in failover scenarios that were discussed earlier. But this is really it. So it's a fully online operation, and you can do it through the portal. We have a PowerShell API to support this. We have a REST endpoint to do it. You can do it through the client drivers in .NET, and you can do it through T-SQL. What you have to do is, if you do programmatically, you will have to poll the system to see what is the status of this operation. And once something is switched, so for example, if you want to do a maintenance operation and you want to do this programmatically rather than doing it by hand every Sunday night, you could just start the upgrade process, poll the system, wait for it to complete, then kick off the maintenance operation. Once the maintenance operation is complete, you shoot the command for going back to the previous performance level. So this is how you choose things, and I will show this in a demo as well.
Very cool. So can we get to see some of those demos?
Absolutely. So let's look into it. The first thing that I want you to show, just briefly, the portal, very familiar. I have 3 databases in here. And I'll be mostly working with the second two, which is an S2 database. You can see here at the end it's a standard 2 edition and performance level. And the second database that I have is a premium database with a P1 performance level. So just as a setup, everybody trust me that those are actually the databases. Now, I'm going to show you a small performance test. And you'll see a way better performance analysis and testing once Charles is here and shows you how we run the benchmark. But this one is a CPU test, and I will show you in a little bit what does it actually do. But first of all, let me kick this off because it runs a few seconds. So just briefly, what I do here is I execute a function that is already created in the database. And you can see on the left-hand side, it is the P1 database, and on the right-hand side, it is the S2 database. And I run 5 iterations of this test, and then I just output the result of the function. And the result of the function is the milliseconds that it actually ran. So I'm going to kick this off in P1, and you can see it start executing. I do the same thing in S2. And so while this is running, let me just quickly show you what this function does. It's already done over here. There we go. So this is the function that I'm using here. And you don't need to understand the details of this one. But it's basically, it runs in a loop. It runs the loop 1,000,000 times. And it does a computation. And so this test is supposed to max out CPU and run into the CPU limits. And then, I just take a start time and an end time and return the milliseconds, the difference that it did. So, going back to the test, you can see on the left-hand side, and let me zoom in a little bit here, the results of the 4 test runs are around 1900 milliseconds. And if you actually look at the 5 runs that I did in a row, you know what I mean when I say it's predictable, right? So those runs are actually always finishing in the same amount of time. And sure, you can say, well, this whole thing ran about 10 seconds, I believe. This is a very short period of time. However, let me kick this off again, and you will see it will come back with the same results. If you look at the results on the left-hand side, those run, it's an S2 database. It has less performance. compared to a P1 performance level. And you can see the result is around 3.6, 3.7 seconds here. So it's around a little less than 2 seconds compared to a little less than 4 seconds. So here you can see how this DTU concept works out. S2 database has 50 DTUs, a P1 database has 100 DTUs. So you would roughly expect it to take double the time to run this test on an S2 database compared to an S1 database. And so the left-hand side, the P1 database, the second run of the test finished. And sure enough, it is again around 1900 milliseconds that this test ran. So you can see it is predictable. It will actually return no matter during day or night, whenever I run it. It will return in this time. All right, so the second thing that I would like to show you is the monitoring of this. So if you look at this small little code snippet, this code queries the sys.dmdb resource stats view, and this returns you the 15-second granular data. So if I run this in the P1 database, and I do a top 20 here, so it shows the last 5 minutes, you will see there were a few intervals right now that had 0 utilization on any of the dimensions here. Which is because I've been talking after I ran the test. However, one of them shows 62.8% utilization. So you might ask, well, Jan, you ran a CPU test. Why is this not 100%? Well, if you paid attention, the total test on a P1 returns in roughly 10 seconds. So it's not the full 15 seconds. It doesn't span the full 15 seconds. Which is why you don't see the 100%. So this is exactly the problem that I described earlier on the 5-minute averages. This happens here too, but on a smaller scale. So you can imagine if you have a more constant workload running, this gets better. Looking at the same thing for the S2 database, and hopefully it's still in there. Yeah, so here you can see the test ran a little longer, and it spanned 2 intervals, and one of them reached 90%. And again, it doesn't run long enough to actually cover those intervals. But this is the idea of this near real-time telemetry, and it's, yeah, as I said, it's available right away. Similar information, as I said, is available in the master database. So on the left-hand side here, I'm querying, and let me get rid of those two, don't need them anymore. On the screen now, I'm running a query against the view in master. And I only output the P1 database. It's called P1 to make it easy for me to know where I'm connected. And here you can see the 5-minute averages in the result. And you can see I played around with this test a little bit before, and like once in a while you see some utilization. But you can also see it's less in the utilization, just simply because it is averages over 5 minutes.
Right.
So let me show you how this looks in the portal as well. So if I choose this P1 database here, go over there, and I click on the monitoring tab in the portal, you can see I already selected the 3 resource dimensions that I'm interested in. You can see them here at the bottom. It's log IO percentage, data IO percentage, and CPU percentage. And you can see on top here there's a graph that plots the utilization. Right now it is scoped, let me actually set this to absolute so we get a proper scale. Right now, it shows you the utilization over the last hour based on 5-minute averages. You can change the scope here to see what was going on over 24 hours. Apparently, it takes a while to refresh. This happens when you demo. So you can see over a longer period of time, and you can go back to 7 days and 14 days. This particular database didn't exist that long, so you wouldn't see anything. Plus, I'm not really running anything in it, so it's not that interesting. But you can see the idea here of this graphing.
So where do you set up the alerts on this one?
So this would be the next part of the demo.
Oh, sorry, I didn't mean to interrupt you.
That's okay. You choose the resource. You choose the resource that you would like to get alerted on, and you just click at Add Alert at the bottom. So it shows CPU, and let's just call this CPU alert. And description, it's an alert, right? you set the subscription, and these things are pre-selected here. And so now what you can do is you can actually choose when you want to be alerted. So you can choose, hey, alert me when the value goes above a certain threshold, or when it reaches a certain threshold, or even if it is below a certain threshold. So you can imagine if you look at CPU and you know you have actually a constant load in your database, hey, all of a sudden it dropped to 0, that might be an interesting scenario for you to look into. Not only knowing, hey, I reached the resource limit, I probably have to do something about it, but no, it's also knowing, hey, something changed my workload, right? So maybe
I'm not using
exactly
that much workload. Maybe I don't need to be at the level that I am.
Yeah, exactly. So yeah, you just choose whichever metrics you like, and then say, for example, 80% is what I would like to get informed about, and then you can choose over which time frame this analysis should be done. So you can do it, hey, last 5 minutes, last 45 minutes, average over the last hour, depending on what your need is and how critical it is and how fast you need to be alert. You can think of, if you have a spiky workload, maybe you don't want to get notified whenever a 5-minute interval reaches a certain threshold. But over an hour, it might be interesting. And then, yeah, you just specify where it should go. And there you go. I'm not going to set it up now, but yeah, you enter the email address and click OK. And then you will get the alerts. One last thing that I want to show here, because sometimes it's a little bit hidden and a little bit tricky to find out, to actually add another metric. I already have all those 3 performance metrics in here. But if you want to add a metric, you click on Add Metric below there. And let's say storage. You click OK. There's one more step that you have to do to actually get it into the picture, which is activating it here. And then you will get the storage number as well. This last thing took me a while personally to figure this one out. I just wanted to let people know, it's not a bug, it's actually there. You just need to click on it. All right, so one last thing that I want to show. I talked about switching performance levels, and Bill showed how it works in the portal. And I want to show how this works through T-SQL. So first of all, in the master database, we have a view that gives you the status of the operations that are ongoing. And I have a small little query. There are a couple more columns, but I have a small little query that queries this information. And you can see here it has a list of databases and what is going on. And if you want to change the addition programmatically through T-SQL, you just issue an alter database command. You specify the database, in this case Fabrikam is one of my databases, and you modify the addition, and as you might remember, it is a standard S2 database. Mm-hmm. So now I'm going to specify the addition premium here. What this does is it moves it into the premium service tier and assigns the lowest performance level. So once this operation is completed, it will be P1 performance level in the premium edition. We have the option to also specify the actual performance level. And this is the SLO objective that you can specify. And this is all documented if you want to look this up. But what happens if I hopefully did this right and execute this command? This is an asynchronous operation. So the command is now received by the system, right? So the system now knows I want to change this database. However, the operation doesn't instantaneously happen. So now you can go in and pull the data from here. And you can see in line 3 here at the bottom, the Fabrikam database, the operations alter database, and the status, it is in progress. And let me get out of here. And so what you would do is you would keep pulling this information if you do it in T-SQL specifically. As I mentioned, this is also available through REST API and through PowerShell. You would pull this information and just wait until this thing is done, and then you're in the new performance level. This can take a while. However, let me actually show you that you can connect to this database. So I just opened a new window. Fabrikam chose the most difficult name here to type in. I just changed the connection string, and now I'm connected to this database, and I can say select 1, which is just a round trip to the database, and you see it's actually online. Right. So during this operation, or while this operation is ongoing, I can connect to it. The database is online, and you can see you can use it as you would normally. let's see. It is probably still ongoing, just to make the point. So you see the operation is still in progress. You can use it. Everything is online. You don't need to worry about it.
Yeah. So is there a way to estimate how long it will take?
We do show a percentage here. Don't have it in this query. It's a little bit, the actual upgrade operation depends a little bit on what needs to happen behind the covers to make this change. At times, if you think about these bounding boxes that we have introduced, at times there's not enough space to give you a bigger bounding box on one of those machines, which requires us to move some things around. And in this case, it can become a size of data operation. The system might not always move you, but might move someone else. But this is generally when you upsize, this can happen, and this can just simply take a while. Downsizing operations are normally in place because you free up space on the machine. So clearly, we don't need to move things around necessarily. But yeah, this is something to keep in mind, obviously, when you choose when you move things around. Yeah.
Okay.
I think that is pretty much it for the demo.
All right. So you mentioned that you're going to talk maybe a little bit more on quota management.
Yeah.
I know Bill talked about it in our first session.
Yeah. Bill surprised me a little on showing those details. I guess he did that on purpose. No. No. So quota management. Bill mentioned actually the most important points here already. So when you sign up and you create a subscription, you initially get 6 servers for a subscription, and each server has a quota on the number of databases. And this actually has been around all the time. So 6 servers and 150 databases. Those quotas are not new. What we introduced is a quota based on DTUs. And yeah, as I said, Bill mentioned it already. What this really does is we give you a set of DTUs, and you can you think of it as a credit, right? And you can use this in different combinations and create different amount of databases with different performance levels. This is a concept that we introduced, or that we learned that we need to introduce during the premium preview. Originally, everybody was restricted to 2 premium databases. So now there's obviously a difference between 2 P1 databases and 2 P3 databases, right? The P3 databases are way more powerful, they cost more, but they also need more space. So to give you more flexibility on how you actually, what is your mix of databases that you run, we introduced this quota, and you can play with it and create databases however they fit into this quota. If you look at the examples at the bottom left, you can obviously create 2 P3 databases and get to 1600 DTUs and you'll be fine. What you can't do is create 160 S0 databases. Even though that is also 1600 DTUs in total, well, you actually exceed those 150 database limits. So this wouldn't work. Same, obviously, if you exceed both, you're even worse off. But in the last row, and I hope I did the math right, if you do 1 P3, 14 S2s, 10 S0s, well, it turns out you reach 1600 DTUs, so you'll be fine, and you only created 25 databases. So you can see how you can play around with these things. You need to be a little careful when you actually max out these quotas. If you want to change performance levels, you just need to keep this in mind. And be
or
mindful.
if you want to do a point-in-time restore on the same server, you have to keep some room for such things.
So exactly. So I guess a good practice, as you said, would be to actually keep some room for these kind of things, and just make sure you don't run into a situation where you run out of quota and need to call us. This is just something to think ahead of a little bit. But yeah, this is pretty much the stuff on quota management. Let's see. And then this concludes the session, or the stuff that I wanted to talk about. I have just so you have all seen it, I have like an overview of this. I don't know if this was in one of the slides before already, but this is kind of like the complete picture with regards to performance for our new service tiers. So you can see basic gets 5 DTUs, then we have 3 standard levels with 10, 20, and 50 DTUs, and then the premiums are from 100, 200, and 800 DTUs. The max sizes are slightly different in terms of storage. However, remember, there's no cost for storage. No matter if you use 1 gig or 250, it doesn't matter. I talked about the hourly billing that we have, and this roughly comes up to $5 per month for basic, and then the range goes all the way up to $3,720 for a premium. One last thing that I would like to mention, and again, Charles goes into way more details on how this works. We published results of the Azure SQL Database benchmark, and we got questions around, hey, does this mean I can only run that many transactions on this database? It does not mean that, right? So this is an example, and this is an example workload that produces this amount of transactions on the database. However, how many transactions your workload produces is really not restricted. So those numbers are examples. They give you a guidance. They show you how we think about the guarantees of the resources when we talk about in basic, we measure it over an hour. In standard, we measure it over a minute. And in premium, we measure it per second. So this means essentially in premium, hey, we guarantee those resources per second, and we go down that route. Whereas in standard, we say, hey, over a minute, this is stable. And in basic, it's over an hour stable. But those are not limits with regards to numbers of transactions. Yeah, so that will be all from my side. I hope I gave some interesting information to everybody, and you had fun in this almost an hour. And stick around for Bill. He has, for Charles. Bill is so in my head because he had this line, right? No, stick around for Charles. He has good stuff.
Yeah, thank you. That was a great session. I think I learned a lot. So now we'll take a 15-minute break, and when we come back, we'll see the Azure SQL Database benchmark in action. Welcome back to the final session of today, or the final module, actually, of today's session. I have Charles here who will be talking about the Azure SQL Database benchmark that we heard from Jan. We'll see the database benchmark in action. There's lots of demos. Thank you. And please, Charles, get us started.
Karthika? We're off to a little bit of a challenging start here. My remote desktop sessions are frozen on me. So that will prove that we are not faking it as we go.
This is all real.
It is all real. For whatever reason, I am just hitting a problem with, it's not even the machines themselves. It's just the remote desktop froze on me as we were getting started. And I'm trying to get that going. Hopefully that will clear itself up in a minute, and in the meantime, we'll dive into the slides. So I can give you a little bit of background on myself. So I've been at Microsoft as a program manager and software engineer for going on 18 years now. I've worked on SQL Server since the earliest versions of SQL Server 7.0. And I've also been involved in performance analysis and benchmarking. I've had a long association with the Transaction Processing Performance Council and have worked in many roles, many capacities there in the TPC. And my current focus is in SQL Azure, SQL Database in Azure, and looking at cloud database performance. All right, let me find out if my remote desktops are coming back for me. I may have to try something a little more radical to force those to restart for me. So, apologize for that. Okay, let's come back in and just get those back so I can get into that. All right. So we do have lots of demos to go today, and I actually want to start by jumping in on the demos, and we will see if the connections come back for me here. So in addition to looking at the demos, the benchmarks in action, we're also going to be doing an understanding of what it means to have predictable performance. I'm going to talk about the purpose of benchmarking, why we do that, what the value of that is. And then we're going to do a little bit of a deeper dive into the benchmark itself, looking at some of the details of how it's constructed, how it helps us do our engineering work, and really being able to share with you why we think that this is a meaningful and interesting way of looking at the overall system performance.
Yeah, so we're getting under the hood look, in other words.
Exactly.
Yeah, very cool.
All right, so let's see if we can actually get under the hood. All right, I'm hoping that that we're back live here. All right, so good. My remote desktops have reconnected. I think we can hopefully get straight into the demos. So one of the things I wanted to do was, rather than do a lot of preliminary discussion around what the various pieces of the workload are and how the pieces come together, I thought it'd be more interesting to just dive straight into looking at the benchmark in action. So without a lot of preliminaries, I'm going to just walk into showing you a workload running. And this is actually running against a P3 database, or our largest SQL database offer. And what you see here on the screen is a tool that we use to drive workload against a target system. What you're seeing here is the particular workload in our SQL Azure Database benchmark. And it is showing us on the screen here that we're getting 535 transactions per second. This is a combined transactions per second over 9 different transaction types. And in this window, what we're seeing is the performance over a 1-hour period. So this has actually been running since this morning when I got it started. And there are a number of kind of interesting things that we can look at when we look at the data that we're seeing on the screen here. So for each of the 9 transaction types, we keep track of the response time of those transactions. We look at the minimum and maximum response times, how many transactions have been done of each type. There's a column here called the RT fence. RT is short for response time. It gives us an indication of how many of the transactions are coming in at or below a particular threshold. And so if we look at the workload running here, what you can see is that in addition to the big number up in the upper right corner there, 535 transactions per second, the response times here are in seconds, average response time. So we have a range of response times for the different transaction types. The read-only transactions, because they don't have to do I/O, they do I/O, they don't have to do, they aren't updating any of the data. They generally have shorter response times. You can see that the transaction that we call read-only light is coming in at 0.005 seconds, which is 5 milliseconds, average response time, with a maximum response time over this last 1-hour window of 2.2 seconds. We can see that 100% of the transactions have completed in less than 1 second. That's 100% probably to the rounding spot there, because we do have perhaps one or a few transactions that came in over that, but when we round it, it rounds to 100%. And then you can see that some of the more I/O intensive queries come in with less than 100% at 1 second response time, but still very good, 97% response time. 97% of the transactions are meeting the response time. And then if we switch over to a graphical view of this, here you can see the performance graphed over actually a multi-hour period. This has been running for quite a while. And you can see that we've been kind of maintaining this steady 500 and 500 plus transactions per second for a long period of time. There are momentary spots where the performance may drop down very briefly. But when we talk about predictable performance, what we really want to look at is the averages, how many transactions are completing within a particular response time constraint. And so, for example, in this picture, we would say this is really very good customer performance, because the very high percentage of all transactions are completing in under 1 second, right? And in fact, the averages are extremely good. They're almost all of these, actually all of these, the average is under 200 milliseconds. So that's kind of a first look at this is the workload running on a P3. And one other thing I was going to kind of orient you to. So the way the tool works, there's a second component of it. And what you see in the second point, this is actually the piece of the tool that's driving all of those transactions. And
so all those blinking lights, each of them is a transaction?
Each of those, yes. So this is giving us kind of an instantaneous view of what's happening. Every time you see one of those squares blink, it was that connection doing that transaction.
Right, and there's a number in that blink which indicates what type of transaction that are happening.
Exactly,
right?
and that number actually corresponds back to the different transactions that we've defined over here.
Yeah.
And so, for those of us who do performance work and stare at this stuff quite a bit, we get quite used to looking at this, and that pattern of blinking lights gives us actually a lot of kind of intuitive understanding of what's happening on the system. If we also kind of look at this picture, which I've zoomed in so you can get a better view of it here, what you see is that this has been running in this state for coming up on 3 hours now. And you can see that we've done a total of 5.5 million transactions since I started running it this morning.
That's a lot.
Yeah, that is a lot. So we'll be coming back to this tool for the various demos through the hour, and kind of getting people oriented to what the pieces are is a good starting spot. All right, so that was kind of our first demo, first look at the tools, the workload, giving you a sense of kind of some of the things to come. So let me now hop back to my slides. So the next part that I wanted to talk about is we've published the performance numbers. Jan was talking about that we've got the DTU numbers, and then we've got performance, which is measured performance. So the slide here brings those two together and summarizes it. And I want to spend a little bit of time, explaining how we think about this, what the pieces are, and how to interpret the data. So we have the 7 different offers within editions, 3 in premium, 3 in standard, and 1 in basic. And each one of those has a DTU rating. The DTU rating is a measure of the kind of blended resources that come together for that service level. And then going from that DTU rating, we take our performance benchmark, we configure it in each of those offers, and then we drive the workload to its kind of maximum potential while achieving a certain response time on the transactions. And so what you see on the rightmost column is the response time constraint that the transactions have to achieve for us to classify this as having met an acceptable level of response time at that level of performance. We could actually drive the performance harder, but we would at that point start to lose we wouldn't have enough of the transactions meeting the response time to say that it was passing.
So that means 95% of the transactions have to fall within that per second
Yes.
time that we have. Okay.
Yes, and so for example, when we run these measurements, what we do is configure the workload. We require that it has to run for at least 1 hour continuously, and within that 1 hour, 95% of all of the transactions have to, actually 95% of all of each type of transaction has to achieve 1 second or better response time. And that's in the premium tier. And what you can see here also is that the response time constraint that we define is more stringent in premium than it is in standard, than it is in basic. Right? And that's because the premium tier is targeted at a higher class of service, and so we feel like a very strict response time constraint is appropriate there. Standard 90th percentile 1 second is actually still a very good response time, but it is not as stringent as what we measure in premium. And then basic, because it's meant to be a more an offer that's more at kind of the individual user. We then define that in terms of an 80th percentile response time at 2 seconds. And then you can see that the units that we use to report the performance, so for premium, we report those in terms of transactions per second. In standard, we report them in transactions per minute because we believe in standard that that's better suited to where that database offer is positioned. And in basic, we report them in transactions per hour. The transactions themselves are, in fact, we're doing the same workload across all of these, but we measure against a different response time constraint. And this gives what we feel is a better way to position the workload across these different offers. All right. So one other point I'd make here is that we talk a lot about predictable performance, and the response time constraint is in fact a very valid measure of the degree to which you achieve predictable performance, because when you look at 95% of all of your transactions achieving 1 second or better response time over a 1 hour period, the only way you can achieve that is by having a very consistent, very reliable level of performance that you deliver throughout that time period. And then when you go to like an 80th percentile 2 second response time, that's still a very good measure of overall performance and predictability, but it clearly is less predictable. You would expect to see more response time variation while achieving that constraint than what we would offer in the premium. All right, so let's go on now. I want to move to another demo, and hopefully my remote desktop is cooperating. From what you saw on the chart, we have measured these different levels of performance across the different offers. What I'm going to do is switch over to another view here where you already saw the P1 performance. I've actually got the same workload running against 5 other databases. So a database that's configured as a P2, a database that's configured as an S2, an S1, then a P1, and a basic. And what I want to show here is that first the difference in performance across those different tiers. And we'll also get a chance to look at a little bit how the response time may vary and how the predictability of the performance is different across the choices here. So what you can see here is this is a P2, and we're achieving 191 transactions per second. This is looking at, in this case, a 10-minute window, 600 seconds. If I were to look at the performance of this over a longer window here, so this is actually looking back over, let's see, a little bit more than an hour, you can see that we've kind of consistently been achieving around the 200 transactions per second over that time period. Let me kind of quickly then look at the others. So here's a P1 achieving roughly 100 transactions per second. Our S2, this is 50 transactions per second. Here's our S1, around 20 transactions per second. And one thing you may notice is that we're actually getting somewhat more variation. There's a little more swing in the numbers. And then when we look at basic, we're coming in somewhere around 5 transactions per second.
And you begin to see more variations as well there.
Exactly.
Yeah.
And in fact, if we were to look here at the numerical data, what you can see, this is actually on our P2. All of our transactions are still coming in above, no, more than 95% of them are coming in with 1 second response time or better. The same is true on P1. If we were to come down to basic, you see here that some of our transactions actually, CPU heavy in particular, one that stresses the CPU more than the others, is actually only at 70% of those transactions are meeting a 1 second response time constraint.
Right.
But in basic, we actually define a lower response time constraint. And so this is actually meeting the response time constraint as defined for basic. All right, so that kind of gives us a sense of looking across the different tiers, what the performance, how that varies across them. All right, so one of the fun things about doing demos and doing live demos is that we get to show you how some of these things actually work in real life. And so one of the things I want to talk about is we put a lot of emphasis on the reliability, the availability of the service. And earlier in the day, Sasha talked about the BCDR. Jan also touched on this. So one of the real strong capabilities of SQL Database is that we are able to deliver this performance consistently with high availability, independent of the fact that there are upgrades, software changes occurring in the background, that independently of changing service levels that the customer would do. Obviously, any hardware failures, we don't want that to ever impact the database availability. And so there are the mechanisms that we use to do that are what Sasha was talking about in his talk, where we have multiple replicas of the database, and one of those is the primary replica at any moment. And then all changes to that data are being replicated to the secondaries in real time. In the event that there's anything that goes wrong with the primary database, wrong or by design, if we were, say, upgrading the service, upgrading the software, changing the service tier, the mechanism that we use to do that is we then fail over, reconfigure to one of the secondaries. And that reconfiguration is done kind of transparently to the client, other than that you may see the session disconnect. And that's the design pattern that everyone is supposed to code to here. And so the session would disconnect within your client logic. You would then reestablish that connection and not know that you had actually changed from one database replica to another. And then you would be on your way. So that's the way it works in ours. we also do look at how the same mechanisms work in other databases and in other cloud services. And I have an example here which I think is an interesting one to focus on for a minute. So this is a actual measured result where we've looked at the performance and the behavior in another vendor's cloud service when we are running workload against it, and then we say we would like to change the instance size on that service. Perfectly reasonable thing that you would want to do. You'd say, okay, I've configured for a certain size, and I've decided I either need more or perhaps I need less for my workload. In this picture, what you see is that we initiate a change in the instance size, and a couple of minutes later, the sessions disconnect, which is fine. We immediately try to reconnect them, but they don't reconnect because the database is not there. The database has been spun down and is then being moved to another piece of hardware. And you can see here that in this example, that it took about 5 minutes before the database had then been reinstantiated on a new piece of hardware, and then performance returned to the previous level. So that's not something that we want to do in SQL Database. If you had 1 5-minute outage every day, you would actually be only at 2 nines of availability. And so that's something that we have put a lot of work into designing around to make sure that you don't have that experience. So here's an example of the same experiment run on SQL Azure. And in this picture, this is throughput over time, and it's measured over probably about 15 minutes or something. And Karthika, I might put this to you. I'd say, can you tell me where on this picture
oh dear.
The failover occurred, right?
Okay. Yeah, I'm going to take a look at maybe one of these flips. To me, it looks like it was probably between that 0.21 seconds and 1 minute and 8, somewhere in between that. But
okay. So that first
yeah, the
dip.
first dip is what looks like, it looks like a big dip, so I'm going to guess.
That's a good guess. And in fact, you're right. There was a performance drop when that failover occurred.
Yeah, but I have to say that it was not as big as the previous one.
Mm-hmm. That's true. But I also have to tell you that it was a little bit of a trick question because, in fact, in this picture, there were 3 failovers. And just to be clear, these failovers occurred not because anything went wrong, but this was a test that we initiated. So we have the ability to control through back-end mechanisms, forcing a database to fail over to a replica. And so you can see here that in fact, where there were 3 failovers, the impact to the workload is short duration. The impact to the overall performance is quite slight. And of course, the database maintains full transactional consistency and data integrity over that operation. So now we get to kind of one of the fun things here. Another demo, but this one we're actually going to try to reproduce for you in a live demo what you just saw on that graph. So I'm going to flip back to my driver machines here. And I'm going to go to, this is a P1 database. This has been kind of running in steady state for quite some time. You can see here that we are kind of maintaining very close to 100 transactions per second. The response times look quite good. And we're just in steady state, everything is working normally. So I have an assistant here in the studio with me who is going to help in executing this demonstration. The mechanisms that we'll use to do the failover, forcing the primary to spill over to a replica, requires going in through some management interfaces that are not publicly available. And in fact, this is running on not a production cluster. This is running on a test cluster. In all other regards, equivalent to production clusters. But the operations we're doing here are things that we can do from a dev and test perspective, but not things that we would ever normally do in a production cluster. So if I can ask my assistant to do the command that will force the database to fail over. And what we will be looking for here is, back on this view, and I'll even see if I can zoom it in here. He executed the command that caused it to fail over. What we see here is that all of the connections that existed were dropped by the server. And in fact, if you look at the message here, this is, each of the worker threads in this environment are then reporting that they got an error. You can even see the error here. It says an existing connection was forcibly closed by the remote host. Communication link failure. So the application logic follows the pattern of saying, oh, well, my connection was dropped. Let me try to reconnect. And in fact, all of those connections were, very quickly reconnected. You almost didn't see the interruption there.
Right.
And
I briefly saw it go yellow and things, and then I saw those errors, and then quickly we jumped back again.
yes, exactly.
It was very brief.
And let me. And then here's our throughput chart, and you can see that on the moment when the failover occurred, there was a very slight impact to the momentary performance, because obviously those connections were all actively doing transactions, and they're doing a mix of transactions. They're doing a mix of update and insert and delete, so they are actively changing data. And so during that brief moment when they then have to reconnect, obviously they aren't getting any transactions through at that moment. But then as soon as they reconnect, then performance very quickly returns to where we were before. So that's our probably most challenging demonstration for today. Although we've got quite a bit of confidence that this was going to work, because this is exactly the same mechanism that is used across all of the production databases. All the time, 24 hours a day. So it's a very routine, well-tested mechanism. What's different here is just we're usually not the ones initiating the failover.
Oh.
So that is, let's see, that's my, I think, second demo. Let me, is it back to the slides? That was my third demo. Time flies. So the last part that I'd like to cover here, and we have one more demo coming up near the end. But I want to talk about how we think about the value and purpose of benchmarking. And this is by way of giving some insight to our customers and our users, how we approach this, what value we derive from it, and how it helps us deliver a better product to you. So the first is that it's super important to be able to measure meaningful database performance. We don't just look at what are the hardware specs on the box, what is the CPU gigahertz and the gigabytes of memory, and say, oh well, therefore the performance is X. We actually are much more concerned about measuring actual performance. And then saying, does that correlate to what we expect to get out of a given configuration, a given piece of hardware? And when we don't get the performance we expect, that's an opportunity to understand why and to dig into the engineering side of it. which brings us to the next point, which is that we use the benchmarks and the performance work very heavily in our engineering. This is critical to being able to build the product so that it performs well, being able to detect at an early stage any performance regressions that may be introduced. The software is obviously always kind of changing and evolving. And then being able to drive our engineering forward to also be able to be offering a better product, better performance on an ongoing basis. We also use the benchmarking as a way to communicate information out to users. What you're seeing here today is an example of that. And we really want to be able to talk in terms of measured performance because we think that that is much more ultimately meaningful to users of our database rather than focusing only on hardware specs. And then the final component of this is that we know that our customers have choices, and there are lots of services out there offering database capabilities. So we also use this as a way to understand our competition. We have the ability and do exercise the mechanisms so that we can go out and measure the performance of our competitors and make sure that what we are delivering and we're offering is better performance and better price performance than what's available through other services. So with that, the last segment here that I'd like to go through is doing a little bit of a drill down to give you a kind of a deeper insight as to what some of the pieces of the benchmark are. This has been written up in a MSDN article, and over time we'll be providing kind of a deeper dive, more details about it. But this is an opportunity to kind of in a live setting talk about some of the design philosophy and what some of the pieces are here. So we refer to it as ASDB, which is Azure SQL Database Benchmark. I've actually worked on benchmarks in many capacities over the years, and I've worked on benchmarks that have kind of spanned a spectrum from simpler to more complex. The approach that I took in constructing this workload was that I stepped back and I said, okay, we particularly want to focus on measuring the performance of database in the cloud. And I looked at that and I said, now, what is different in the cloud that we need to measure that we either can't or the existing tools are not well suited to? And what I found in thinking about that was that if we look at the box world, where we do our packaged product, the databases there are very highly evolved. It's a very mature technology. Databases have been around for decades. And the databases, the capabilities have become very evolved, which is a wonderful thing. The benchmarks that we use in the box world have become highly evolved with the databases. So the amount of coverage, the complexity of the workloads has evolved as the database capabilities itself have evolved. In looking at the cloud, there's an interesting distinction to be made. When we run a database in the cloud, the things that are fundamentally different there are actually mostly not around the internals of the database. There certainly are things internally that are done differently, but an awful lot of the pieces actually are very similar between box and cloud. For example, how you walk a B tree, how you do a hash join algorithm, those don't change just because you're running the database in the cloud. What does change in the cloud is the environment in which the database is running. So the fact that the database is multi-tenant, or running in a multi-tenant environment. The fact that the I/O subsystem around the database is typically quite different than it is in the on-prem box world. So that means that there are certain aspects of this that are just fundamentally different that we want to think differently about. And in thinking through that, the conclusion that I reached is that I really wanted a workload that became simpler, right? That actually let me focus on individual components within that environment so that I can understand the basic building blocks within the system. And that's a different approach than a lot of the more highly evolved benchmarks have taken. So let me now kind of go next layer deep there and explain what the components are within the ASDB benchmark. So the schema itself is fairly simple. There are 6 tables. I categorize those as fixed tables, tables that are the same size regardless of the how the database is scaled, the transaction rates that you're running against it. There are 3 scaling tables, tables that scale proportionally with the transaction rate. And then there's 1 growing table, a table that where rows are inserted and deleted, so it has a more dynamic nature. The database has primary keys and alternate keys, single and multiple columns. That's a very kind of basic operation within the database. It actually doesn't employ any referential integrity constraints. Not to say that those aren't important. They are widely used. But in the context of this workload, they don't actually contribute to understanding cloud performance particularly. And then the schema itself contains a mix of integer, numeric, date, and text data types, really to provide a kind of a balanced, varied mix to exercise a range of data types.
Can you go a little bit more detail into that scaling type of table? I think I got the fixed and the grow, but I'm not sure I entirely, got the full gist of that scaling table.
The scaling, the scaling itself. So there's 3 tables. Each of those will grow proportionally to the target transaction rate. So, for example, on a P1, where we would say the transaction rate is 100 transactions per second, these 3 tables would be 5 times larger than on an S2, where the target transaction rate is around 20 transactions per second.
Yep, got it.
Okay.
Yep, great.
The other interesting thing to know about the scaling tables is that we size them so that they, particularly the largest, the naming here, SXL stands for scaling extra large, is sized in particular so that it doesn't fit in memory. We don't want to be running an in-memory workload by having a table that is larger than the physical memory. We can ensure that we get a lot of physical I/O when we do certain operations against that table. And then the last about the characteristics here. The schema doesn't have complex relationships between the tables because, again, that's not particularly interesting from the perspective of exercising the cloud aspects. But the tables themselves can be scaled and grown to be arbitrarily large, which is a really nice attribute that we can always make the tables large enough so that, for example, they'll never fit in memory. Let's see, moving on to the transaction mix itself. So there are 9 transactions that are exercised in the workload. And these primarily map to the very basic operations, the very basic DML operations that every application does in a database. So we have 3 transactions that are doing select operations, light, medium, and heavy. The distinction there being around the amount of work that's done in the transaction and the amount of I/O that it's likely to do. Update, doing update statements, again, light and heavy, depending on the amount of work within the transaction and how likely it is to exercise I/O. Insert, again, same light and heavy characteristics. A transaction that does deletes, and then a transaction that is considerably more CPU heavy. And this is an opportunity to exercise more of the CPU dimension without necessarily bringing in I/O or logging. So this mix of operations exercises kind of the most fundamental code paths within the engine. It gives us an opportunity to exercise a range of physical I/O patterns. And the way the workload is constructed, we can run a large number of users against it. We can increase or decrease the number of users, the number of connections. We can also scale the workload so that we are able to drive the database into saturation, which is a really valuable way of understanding, at what point things, exceed their thresholds, or at what point something might break. And then I think we have just one more slide here talking about the benchmark workload. The value of this approach is that it's a very useful tool to be able to dynamically reshape the workload so that we can look at varying dimensions. For example, by altering the transaction mix, we can change the read and write balance. Any given workload is just going to be one point on a spectrum. We recognize that customer applications have very widely differing characteristics. So to be able to pattern after a particular workload that might be much more read intensive, we can change the transaction mix here to make it become a more read intensive workload. Also the CPU and I/O balance, it's very easy to turn knobs within the workload to make it more I/O heavy or to make it more CPU heavy. There's also a balance there between how much I/O you're doing against data pages within the database and how much I/O you're doing because of transaction logging. We can change the database size, kind of scaling it up or down arbitrarily, as I mentioned before. Having more or fewer users, and then changing the pacing. So users go through a cycle of how much work they're doing, and they do an operation, and then they say, okay, well, I will wait for a period of time before I do another operation. By changing that pacing, by having the connections either go faster or slower, we can alter the overall characteristics of the workload. So that combination of kind of knobs and capabilities has proven to be really useful in helping us exercise lots of the pieces within our system for engineering purposes. And one of the last demos I was going to do here was see if we can go in and actually on the fly show how by turning those knobs we can dramatically alter the behavior of the workload. So let's go back to one more. Let's see, for this one, what I'd like to do, I have my P1 database here, and this is the one that we did the failover on. It's continuing to just kind of run along in steady state. And I'm going to try to do one more thing here. So as Jan showed you earlier, oops. As Jan showed you earlier, there is a new stored procedure that we are able to use to see the resource utilization within the system. So in 15-second granularity, it shows you the CPU percentage consumed, the I/O percentage, the log, and the memory. So this is actually then looking at that P1 database server. If I execute the query, and let me zoom in a little bit here. Oops, excuse me. So what we can see here is that for the workload as running, we're actually consuming all of the data I/O. That's coming in at essentially 100%. We're consuming roughly 60 to 70% of the CPU. Log, we're not stressing as much. And we're essentially using all of the available memory. So that's with the mix that we use to measure the overall workload. If we, now I have to maneuver my way back to my other remote desktop here. So now if I, in this workload, I can change the mix. And one of the things I'm going to do is I'm going to, on the fly, tell it to change from a more balanced mix to something that's going to be very CPU intensive. And I will do that change. Oops, hang on a moment. All right. Excuse me for a moment. It is a live demo, so it doesn't always work the way you want it to. My operation to change the mix was not going through the way I wanted it to. I'm going to fix that right now, hopefully, by just restarting. All right, it looks like that one is not behaving the way I want it to. Oh, actually, this one is, though. Okay, that demo, I need to stop. Let me do this one more time. Karthika, this proves it's not
real.
It's not a canned demo. It's real.
Yes, it's real.
And
we're seeing it in real time.
But
right. I think this really comes back to a lot of what we've talked before, predictable performance. I think it's really great to see that in action using the database benchmark.
Yeah, and it's we've gotten a lot of insight out of it. Let me try this one more time and see if I can get it to work the way I want this time. Still having a problem with that part of it. We actually are coming up close to the end of the hour, so I think I will abandon this attempt. But this is where we have this ability to change it on the fly and be able to exercise these various dimensions independently. So if we just come back here to, excuse me, to our slides. So I just wanted to kind of do a quick review and wrap up on kind of what we've covered here. Given an insight as to how we quantify predictable performance, how and why we do benchmarks as a way to look at actual performance. We want to truly exercise all of the internals of the engine, not just rely on the hardware capabilities. The ASDB benchmark has been a really good tool to get that deeper insight, both into our own database service and looking at other offers in the market. And I think we've gotten probably about a 75 or 80% success rate on our demos today, which I will say is almost a passing grade. And hopefully we've kind of completed this with a better insight as to the ways in which we deliver predictable performance for our users.
Yeah, thank you very much for a great session.
Thanks.
That brings us to the close of the Azure SQL Database session for today. Thank you all so much for coming and listening to us, spending the time here. Hope you all learned something new or had your question answered that you were looking for. My last request of you is please don't forget to take the poll and let us know how we did so that we can make these sessions better as we go forward. Thank you again.
Thank you.